Well, hello everyone, and welcome back. Hey December DA, and Mindbill says hello, spoken like a true Odin developer right there. And Xluxy, hello, welcome back everyone. Let's see if I can untangle my cables here. What's going on, everyone? Let's get the visual there out of the way. It's nice that we have some viewers here, even though it's like, even though we are in the middle of the day. We're not doing C3 today. No, C3 was a slight detour. C3 and Odin, both of them, were small, fun side projects. Might lead to something larger in the future. I'm falling off my chair almost. Let's see, we have some sound here. It's quite low. Yeah, I think it's actually probably pretty good. Let's keep it pretty low for the stream. Yeah, the C3 and Odin stuff. They are both sort of, their languages I don't really know. Well, I know them a little now after having done a few things with them, but they're not really languages I have any experience with, and I'm not gonna change programming languages mid-project. That would be, well, there should be a really good reason for doing that. And so they were just sort of like initial first tests. Let's see what happens if we add some support for C3 and Odin into the game engine for building mods. And I managed to do that. I think especially C3 turned out pretty nicely. It's the beginning of a pretty nice modding SDK. With Odin I wasn't quite capable of doing everything I wanted quite yet, but I'll get there eventually, I'm sure. It's 11 AM for me. It is 12 PM, I guess. I don't know the PM and AM thing is. Like, I run on a 24-hour cycle. But it's noon here in Finland. So I guess I'm probably like 1 hour ahead of you. Xluxy. And yeah, it's not a weird time for me at all, except of course like most people around here are at work, and I am also at work because I am in fact working on this game this week. I thought we were going to do hot reloading for C3 mods. The hot reloading stuff. The hot reloading stuff probably goes into the C++ part of the code base. We have some old stuff here. Yeah, look at this progression here, by the way. This is not something I've noticed until now. This is the first thing I drew. I don't remember exactly what we did here. This is something with the wheel suspension thingy, and here's like the architecture of the thing. Then I've gone like larger and larger, and now we're at this size. I didn't notice that until now. Probably doing Zig hot module reloading. Yeah. I am, well, it is SIG in this case, yeah, but it could be anything really. It is SIG because it is the main library that we want to actually hot reload. Let's draw a little thing here. See if we can untangle this thing, this mess. So, you know, we have the exe. Let's call it, I can't draw with a mouse for shit, but let's call it traction point. Traction point. I don't have a a drawing tablet. Oh, that looks wonderful. .exe. This is C++, right? C++. And then we have basis DLL. Basis DLL. That's also C++. That's the core engine library. And then we have means game. The means game sits off here somewhere to the side. Let's put it here. Means, by the way, means haha, pun not intended. Means game. So means traction point. It's also a DLL. DLL. Like this. And this is written in Zig. And then this guy kind of like loads that guy, and that guy loads this guy. That's how it works. So you know, these two things here, this exe and this in this core engine, are kind of reusable in a sense. And then this is where you put all the game specific code. So all of this stuff, you know, gravity crane component, for example, this is SIG code. This goes into the means game DLL. And then you can have a bunch of mod DLLs, right? So you can have the thing that we worked on last time, which is the C3 mod. I keep running out of space here. That's a DLL. Let's do it open-ended. Odin mod. .dll. I really should have my drawing tablet connected to do this sort of thing. I'm sorry. And this is, of course, this is written in C3. This is written in Odin. This would all be loaded by the engine as well, like this. And you know, you could have a Jai mod written in Jai, so there would be a Jai mod. .dll. DLL, like this, etc. This is kind of the architecture that we're working with here. Now, these are all loaded. This means game C3 mod, Odin mod, and this potential Jai mod are all loaded dynamically by this basis.dll thingy. We can see it here. If we go to dynamic library, it's pretty ugly looking code here. Dynamic library load library, and we get a handle to it. That's how we load all of these, including this means game DLL thingy. We also load some other things as DLLs, like the NVRHI rendering API, and we load physics. We load all of those through this one load library call here, right? The entire gameplay code is mostly Zig. It is, yeah. Of course, there are things in C++, like, you know, a trigger component, for example, this kind of thing, which can be scripted using AngelScript. So if you have the game engine, the editor here, and we go to, let's go to the refinery blockout level. It's going to take a little while to load, but we can wait for that to finish. So in here, when you load up a level, I don't know if I actually showed off the editor in the previous two streams. I bet I probably didn't. Yeah, it's building the light probes there. When that's done, this should be kind of smooth. So we have just a whole bunch of triggers and things like that in here. So if we go to draw all the triggers, you can see I have just like a whole bunch of triggers. All of this is covered by trigger essentially, because we need to know if the player is inside this facility or not. But here we have a trigger that just covers this junction. Let's see if we have any of those trigger icons. They tend to be underground. It's these lightning bolts here. So this is a trigger. You can see that we can script this guy to do things. Player has been at monorail station B, and then we send a message based on that. And so that is, I would argue that is gameplay logic, and that is also found here in C++. But this is a very sort of general purpose trigger thing. So not all gameplay logic is in Zig, in that sense. We also have a bunch of it that is found here in this core DLL here. But most of the like game specific things, like for example this gravity crane component, which of course is this gravity crane that's found here on the mother vehicle. This thing, which we can use to lift things. Let's spawn some boxes here. Burp. Needs to be a bit closer to it, I bet. There we go. Now we can lift it. This kind of stuff is found in Zig. I don't know why that thing isn't getting lifted now. Is there a bug? Is there a bug? Oh, there we go. Seems somehow like the effect isn't getting turned off. That's interesting. Let's restart this thing. Did I break it? Off to a good start here. Oh, and we probably want to actually... Well, let's just go into the level and see what happens. Depot. That's the cargo crane, that's the gravity crane. Yeah, the effect isn't turning off. Ah, we have a bug. So I upgraded to the latest SIG version yesterday, because the latest SIG version has some quite wild changes to their I/O, as I'm sure you've heard if you've been following latest SIG happenings, right? And so I'm sort of thinking that we have a bug here that's somehow introduced by that. Let's see if we can actually figure that out. Gravity crane component. A tractor, if I remember correctly. This thing probably has a, yeah, here we go, displacement effect. Displacement effect render a pointer. So probably, yeah, kill effect. It's right there, but that's probably not what we want. We want to actually just like set it. Yeah, we set the strength. It should sort of like fade away when you stop it. So let's just print the strength here at least. See, this is what I would like to do today. If I enable this call here, like this, and just recompile this thing, I would like to be able to just like see it here, but we can't do that. So we're gonna have to shut down the game so that we unblock the DLL, essentially. And now we can see the VFX strength. So we have a little bit of a state machine here. We're starting the VFX here. Oh, we can't do that because the editor is still running. Let's get rid of that completely. Bye-bye. We have a little bit of a state machine going here. We start the effect here. We update the effect here. And then we stop it here when the strength is at 0. So maybe we should actually even... should put a... I was gonna do it without the F there. Visual Studio on your trying to be helpful with like adding another set of braces or quotation marks here. Let's see. So VFX stop, something like that. I bet we're never getting here. Actually, maybe we're, because it's actually kind of, it's staying quite strong, so I think we actually never actually, you know, bring it down. Let's see, is active. So is active is a propagated value. Yes, propagated value handle. And it kind of looks like that thing isn't being actually propagated properly. That's interesting. Let's actually we can use a significantly simpler level for this sort of thing. This is not what I was, you know, supposed to do at all today, but hey, game development for you guys can't be helped. So gravity crane, turn this on. We can see, okay, VFX strength is at 1. We can probably lift these boxes. At least that smaller box there is liftable with this thing. I don't think the bigger one is. It's too. You can sort of drag it around, but I don't think you can lift it now. So now if we shut off this thing, you can see that the logic works because we're sort of like we're letting go of that thing. Let's spawn in some more low dynamic objects. Oops, here we go. So this thing is actually not on now, which means that this doesn't do anything, right? Even though you see the effect there, and that's bad. So now if we start it up, you can see that, whoa! Just lifting the entire thing to the air because there's so much force suddenly being applied. But yeah, you can see the VFX strength is 1, so that's bad. We don't want that. Hello, Nikita. Good luck today. Have fun. Thank you. Thank you. I will try to have fun. Currently, I'm fixing a bug. Right, so let's go and have a look here. Still on this. That's the wrong component though. Here's gravity crane component. But yeah, if we had hot reloading here now, this would be significantly easier to actually. It's the attractor we want. Sorry, it would be significantly easier to actually debug this thing, right? So VFX strength. Adjust the VFX strength up down depending on the active state. Active. So active is for some reason not getting set to false when we toggle it here. So it is probably getting set to false on the server, but not on the client. Isn't that fun? So this is in the tick. So this is the fixed rate update on the server. If we are active, we apply a radial force within some range. If we're not on the server, i.e. we are on the client, we go here to the else, and we read the same is active thingy there. Okay, so let's comment these guys out. I'm gonna take this and put it here. That can be it's just a boolean. So we do client active. Client active is, well, it's essentially that one, so let's put it beneath. Active is there. And here we can actually put this. Let's put it there. Just read it again. So this is on the server, right? And of course we can try this out in pre-alpha 3. Now we can see client server active false. Alright, gravity crane. We enable it and now they're both true. And then we disable it and now it's true false. Look at that. It's not getting reset on the client for some reason. Wow. So this thing never goes away. How fun! This is not what I wanted to do today, but okay, let's have a look. Maybe we get to debug some of the network layer stuff here. Let's do game state manager. It's probably actually client game state manager. So we're serializing where, let's see, reliable propagated values. Is that a reliable value? Let's have a look. You can make it reliable or unreliable, kind of like based on the importance here. It's probably set as a reliable value because it's just like set once. It's not something that you spam all the time. Those things are typically unreliable because by the time you've actually gotten the value, it's probably out of date. So just like you kind of like don't want to make it reliable. Yeah, reliable propagation is set to true. Immediate set to false. Initial value false. Okay. Okay. Then there is a function here in the library API, which is called something like PV update. And this would be a Boolean. Would it not? There we go. Update bool. I had it here. Where was it? There we go. Yeah. So let's run this, and then I'm gonna set a breakpoint there when that actually happens. So now if we put a breakpoint here, and then we are triggering breakpoints immediately apparently. Yeah, that could be kind of tricky. Yeah, so what happens here is that it gets the pointer to the propagated value. Boolean is here. And then calls set propagated. Sets the value of the thing. And then if we have a value changed callback, then we set that. So that might be actually something that's kind of interesting to see if that happens. So we're going to go to the attractor. I'm going to create a function here. Somewhere, maybe above this one, doesn't really matter. Active changed. We can do it self, and then we need it's called something like value time. Yeah, so this is what the prototype should look like. So we have the value active in this case. It's a Boolean. And then the system always feeds whether or not that's a local change or remote, and then what the value time is for that. So here in create, where's create? Create is here. Yeah, if we are on the client, let's hook that up. So self is active, set value changed callback. Init method. Receiver is self and active changed, like so. And here we can again print active changed on client. Active, I'm missing an I there. There we go. Sure, we can actually print whether it's local or not, like so. We don't really need those for anything. So let's see what happens now. Oh, I need to shut down the game, of course. And maybe we should take these guys away so we don't spam the thing. Not really sure how the Zig upgrade could have broken this, but I mean, anything is possible. I kind of thought I tested it quite thoroughly, but evidently not. So gravity crane, you can see active change on client true, local false. Active change on client again true. Ah, so it does get called, just that the value is not what we expect it to be. That's stupid. What if we destroy this guy? Things just fall to the floor there. Let's create a new one. So we get one that is doesn't have the incorrect state. And then we can. Oh, we need to set it as the avatar first. There we go. And then we enable this guy, and that's all. That's all fine. And now we need to put a breakpoint here and see what actually happens here when we set this. We can start by actually going into the entire network layer. Probably want to go all the way here, maybe. See what's value. It's a bit difficult to read this optimized code. Yeah, they're all optimized away, unfortunately. Propagated value H. I'm looking for a place to put an optimize off call. Like here in Zig, we can see that, okay, the value is true. That's, of course, that's not good because it's not supposed to be true. But what is it here in C++? Is it actually true here as well? That would be interesting to know. I guess we're just gonna have to quite simply build this in debug mode. Can't be helped. That at least should tell us where things go wrong. What does value time mean? Time in milliseconds when the change occurred. Yeah, exactly. So there is a so-called value time concept for the propagated values. I think it is in milliseconds since the game began, when the actual change happened on the authoritative side of that value, of that propagated value. So you can have values that are kind of owned by the server, so the server makes changes to them. The client can also make changes to them, but if the server makes changes to a value and it is owned by the server, the client will then overwrite its own values with the values that come from the server. So the server gets to sort of correct them. You can also do it the other way around. You can have values that are owned by the client. That's not something that we do in Traction Point at all. Everything that's propagated is owned by the server. And so value time basically just means it tells you when that change happened on the side that owned the value. I don't really use it. I should perhaps even just like remove it from at least from the SIG interface, because it's not really super interesting to know necessarily. Then the local change, this boolean here, that means that is this code now running on the side of the network that actually changed that value, right? So if you have a handler set up, a callback set up for when this value changes on both the client and the server, then the local change is true if the local code kind of changed it. It's false if it was propagated from the other side. That's kind of how that works. Right, so we're building a debug version of the game engine here, which is going to be super slow. Luckily, we have a very small test level, so it should be kind of alright. But the debug version of the engine is super slow. We've spoken about this in the past. I will build a debug version of the game code. I have this handy little Boolean constant here in my build script. Because normally, actually, what I do when I develop this game is I use a debug version of the Zig code with a release version of the engine, because then I can debug the Zig code while the engine is fast enough. It's in release mode. But now we don't want that. We don't want to build debug into the release game directory, so I set that to false. And as you can see, building this thing actually takes a while, because we're building like physics and everything. So yeah. But yeah, to go back to our beautiful drawing here, what we want to actually hot load is this code here. If we can hot load this DLL, hot load, then that would be nice, because then I could make changes to this guy while I'm developing the game itself, and this thing would just like reload this thing, and that means that like most of the work actually goes into this core library here for hot loading it, because this guy needs to like unload the previous DLL, somehow copy over, or rather probably the order is like figure out that a new DLL has been created, load that, then copy over any memory that we need from the old one, and hook up the new one, and then unload the old one, something like that. And that logic will need to go here, at least mostly here in this DLL, the core engine C++ DLL. I'm sure there's a little bit of stuff that's going to go here in the Zig DLL as well. But that's the idea. Okay, so now we should be fully built here. Let's see if we can run this thing. Oh, we're loading into the heavy level here. Let's not do that. You can see we have like one frame per second or something like that. Yeah, there are a bunch of issues, a bunch of reasons why the debug version is so ridiculously slow here. I do like just a whole bunch of additional checks. Now I don't know why it is this slow. Are we doing like a little bit of death spiraling or something? Might be. Let's try to pause this thing. Yeah, we're gonna go to 60 frames if we're pausing it. Wow, this is really slow. I wonder if it's like the physics or something that's causing this crazy slowness. I should really look into this. Let's try to delete some of these guys. It's almost impossible to work with this thing. That's not good. Let's do plane and car. This should at least be somewhat fast to load, because there's really nothing. Yeah, you can see now it's 60 FPS. I think it's probably the physics that is causing that. But see what happens. So if I spawn a mother here, 26 frames. It's not great, but it's usable at least. Okay, so set that as the avatar, and we can use the gravity crane. We can toggle it on, and we can toggle it off. But let's see. Now I want to go into PV update bool. Let's look for that. Update in Zig. Yeah, I think this is the thing. Let's put a breakpoint there, and then just boink. Okay, and here we go. Oh, look at that. Yeah, that looks like value corruption to me. So it's 254. 254. Where's my call stack? Here's my call stack. I do wonder if we're actually getting that value kind of like incorrectly set. I have seen this before, by the way, and it turned out to be a Zig bug at the time, but I was thinking that we would be way past those. So you can see here probably value is false. Look at this, value is false. Set in CPP, still false. Still false. And here is true, 254. What? What? What's that about? Set bool. What does that look like in Zig? Set bool. It's probably called something like generated function point, generated bind types, something. What is it called? Types. Generated types. Set bool. That's not the correct one. That's not the correct one either. This is the correct one. So it is a function pointer in Zig. It takes a U64 and a boolean. Call convention C and returns a void. Okay. And here we have it. And this is false. U64, yeah, that's that one. Value bool. 254. What? Is this like a Zig regression or what is going on? Kind of looks like it is in my mind. As an American with a poor sleep schedule, I welcome the European with a probably normal sleep schedule. I have a somewhat normal sleep schedule, thank you. As I wrote on Discord, actually my phone died on me yesterday during an OS update, so I was actually up quite late just like reinstalling things on a new phone. So yeah, my sleep schedule wasn't the best last night, but it's typically quite okay, I would say. Rightio, this is worrisome. I don't understand exactly what's going on here. Because the value is false here, and we call it through a function pointer, and it appears as 254 on the other side. This is the reason why I have in the past been using something called int bool in my bindings. Let's see if we can find any of the int bools here. An int bool, of course, is just a bool. It's an int rather. It's an integer, but it's kind of like communicated here to whoever reads this. That okay, this is actually a boolean. We just wrap it as an int, as an integer. Isn't a zig bool 1 bit? I don't know. Is it? Maybe it is. Let's see. I mean, it's possible that you are correct. Bool. True or false? C description. Well, the C equivalent here is bool, and in C, a bool is 8-bit, if I am not mistaken, right? Packed struct. Each field of a packed struct is implemented as a logical sequence of bits. Yeah, well, we're not in packed struct, so that should be fine. But the mere presence of this thing here, where they say that, like, you know, in packed structs a field uses 1 bit, that kind of tells me that, like, outside of packed structs they don't use 1 bit. So I think it's 1 byte, just the same as in C. But I might be mistaken. Oh man, this is unfortunate. I didn't want to do this today. Didn't want to do this today, but this is kind of almost like a deal breaker for me here with this whole version upgrade. What we can do, and it's not really, doesn't really affect the hot reloading thing, is that we can downgrade the version. Wouldn't really want to do that though. That would be kind of unfortunate, right? So the way this has worked in the past is that if we go and have a look here on the bind-a-lot file, this is the file that I use to generate these bindings. We have these int bools all over the place. Int bool. Oh, we only have 1, do we? We used to have a lot of them. I've probably been replacing some of them. As here you can see, we have booleans. Yeah, we have a lot of booleans. How does not everything blow up if that thing blows up? I mean, you are correct in the sense that, like, if we have this, the fact that it seems to be 254. Let's go to calculator. and we do 254 in binary, I can imagine there's something with like a single bit to 1 byte conversion that's going on here. That doesn't work properly, right? I think it's 1 byte in C++, but 1 bit in C. Let's ask AI. How many bits does a bool occupy in C? 1 bit. A bool takes 1 real bit, as you only need 2 different values. However, when you do a size of bool, it returns 1, meaning 1 byte. For practical reasons, the 7 remaining are stuffed. You can't store a variable of size less than 1 byte. So, I'm pretty sure that we are talking about 1 byte booleans in C as well. That would be my guess. But yeah, I agree that the fact that we get that as 254 kind of suggests that there's something with like type conversion going wrong. I'm just searching here for if we find anything interesting here. Passing Boolean parameters to magic code is in line 254. That's not what we want. See, the reason I'm confused here is that, like, I'm passing booleans all the time, and like, what is it with this particular one? Where is it actually coming from? First of all, let's see. Attractor is here, so it's a propagated value handle of bool. And we actually create a propagated value of bool, not handle, but value of bool. And we give it a type, and that t is stored here. So here's where we actually store that value, that false, in Zig. And then when we actually use that, go here somewhere, and we set it to not be true here, toggle active input. If you give it true, it should be 255. Nah, it should be 1. It should be 1 if I give it true. See what happens here. If we run this, this should now be running the oh yeah, we do a few of these. Oh, I'm setting something, am I? Toggle active input. I shouldn't be. What? What? I'm not toggling any input at all. What is happening? Or is it actually just that? Yeah, okay, it's just that the debugger in Zig is a little flaky. It doesn't actually do anything here. Yeah, okay. Well, we need to probably go in here And then we hit it from some completely different place, don't we? Yeah, send the back data. This is actually completely fine. Okay, man, this is getting tricky here. Let's do a set in CPP. We can put a breakpoint here, there. Now we should only be hitting it. Yeah, we're hitting it with some other things as well. Okay. It's tricky to debug, I tell you. Okay, we're gonna have to do something to help out the debugger a little bit here. Let's add like a printf here. Toggle. See, what we're actually doing here is we are debugging SIG code with... Oh, I didn't build that. Debugging SIG code with a C++ debugger. I don't think there's any SIG compilers, specifically SIG compilers around. That needs to be just print when we're not formatting anything. And so the debugger gets confused quite often actually with SIG code. And it seems to be doing it again. Aww. Aww. Yeah. You see, toggle active input is false. Oh man. Now though, we want to actually go here and set this to true. One day you might just get frustrated and make your own debugger in MSVC for SIG. Yeah, that is it's possible. It's not outside the realm of possibility here. Okay, let's see. Now we should be building the correct one at least. We're still hitting it though. It makes it super tricky to actually do anything about this. Ah! Okay. In that case, let's attach the process here. Jump it in. The debugger is already attached. That's true. So it's actually just easier to run it from there. I could have detached it from there, but like let's not kid ourselves here. So, mother, hello, and we want to go to probably here again. Let's put a breakpoint there. Oh, I need to do the dance with the whole. What happened? Hello. There we go. Camera. Yeah, it's a bit difficult to use when it's so slow. Gravity crane. There we go. See, we have another. This is the interesting thing. We have another boolean being propagated here. When I click this bloop, another boolean. What is this other boolean that we're setting? Let's have a look here. Stepping through the entire text stack almost. Role menu visible. Role menu visible is also a propagated value boolean, I bet. Here we go. Role menu visible. Init context true, false, false. And so it's true, it's reliable, it's not immediate, and its initial value is false. I think it's the same thing actually we have here with this problematic one. True, false, false, yes. That's the same thing. Now this guy is just behaving completely fine. That's the interesting thing here. And now we're setting it back to false, I bet. Let's step through a little bit more, a little bit more. Oh, now we're setting it to true, okay. And now we're setting it to true in C++. Now we're setting it to false. And now it's coming from Zig. It's false, it's false. It's false all the way here, and then it's false still when we are in C++. See, this is the same thing. This is the threshold from Zig code into C code, and it's false, and that's good. So how in the world is that thing? Oh, can I not enable it now? Can't seem to enable it now at all. Okay. What? Are we setting it to bool, like false every time now? No. There we go. Okay. Now we are. Now we're cooking. And now we're getting through 254 again. That's so bizarre. Why do we get it? Why do we get it as a true value here? Makes no sense. And here's false. Maybe I should. Can I actually change the name of this stream here for at least for a little while? Let's see. Yes, I can. Debugging Zig C++ interop issues. Because that is what we're doing. We're not doing any hot reloading at all, unfortunately. Even though that was the plan. You just invert it and get yeah. Yeah, see, that's something like that would make sense if it was consistent. But the issue is that I'm using these propagated values, the Boolean propagated values, all over the place, and most of the time they work great. Here they don't. So that's weird. I think the Boolean is wrapping around. Yeah, something like that. Something like that is clearly happening. The reason I'm confused here is like why does it do that with this one, and it does it consistently when the other ones work well. The other ones work just fine. Like this in-game menu logic here, for example, role menu visible. True, false, false. Yeah. And this is a propagated value bool. So it's exactly the same thing. This guy works completely fine. Like we had two data types, two exactly similar data types, or at least like seemingly exactly similar data types. And one works great, the other one doesn't. I mean, obviously they're not exactly similar because this one gives us crap. But like, how can it give us crap? That's what I want to know. Yeah. Because like we have two booleans here now. We have propagate value. Propagate val is true, and then we have val, which is true, and then 254 in parentheses. Well, it's a const bool reference, so that's probably why. So, like, are we writing garbage into that value? Is that what we're doing here? The interesting thing here is that the SIG side of the code claims that it's false. Where does the value originate from? Well, it is essentially here, right? This is where it comes from. This value is sent by value, or is it? Or is it? Let's make a little thing here. Let's do a little thing here. Oh, you know what? Could this be some kind of weird aliasing issue with how SIG does these things? Let's... Okay. I have many thoughts now in my head suddenly. Let's have a look. Propagated value. There's the call. We are not in WASM, we are here. So basically we can do this value storage is value, because it will get cranky. It's like, it's unused local variable. Well, what if we just use its address for something? Then the compiler should be fine with us actually doing that, right? The compiler should know that, okay, it might know that we're not doing anything with it, but it should see that, okay, we're using the address of it, so we should be able to build at least. That's my plan here. So now we're gonna go to build. I'm gonna go to this and set it back to, actually, yeah, it should be true. It should be true. So we should be building a debug version of the SIG code for use with the release version of the engine. Let's do that. See if this now fixes it. So what I'm thinking might be happening here is that when we toggle this guy, there's our toggle here, we're getting a temporary that we are setting, and here we are, we're passing it by value, at least seemingly, but I don't really trust the SIG compiler now with these things. So okay, that succeeded. Let's try to run this and see what happens. It's a bit tricky to say where the value originates from, because like SIG has this idea that it passes parameters to functions by value, but it also has this fun little thing where it tries to sometimes pass values by reference if it figures that they are large enough and it makes sense to pass them by reference instead. It's sort of like the const reference thing in C++. So turn it on, turn it off. Look at that. That fixes the bug. It fixes the bug. How stupid is that? Hey. Here we go. That's a bug fix right there. Okay. I need to probably report this to the Zig guys somehow. I need to figure out how to actually. It's probably an API, right? Yeah, here. Make this a bit larger for you guys. We can bask in the glory of the bug fix. So, what seemingly happens here? What seemingly happens here is that this guy is somehow passed not by value but by reference or something like that. And when we call this thing, its value is garbage or something. I don't know. I don't know. This is weird. If we don't have that there, it is cranky with us, because then this thing needs to be a constant. Maybe that will also work. Let's see if that works. But this is one of the more confusing Zig bugs I've seen. Oh, it's running, yeah. Again, what if we had hot code reloading? Code hot reloading, whatever. Yes, now we are assigning it to a constant. I don't exactly know what this thing is going to generate for us now. I mean, we could look at the disassembly, but I don't really feel like doing that, to be honest. Maybe we could just run it here from this now that we're friends with Zig again. We can run it from here, and gravity and gravity. Yeah, see, now it doesn't work. Yeah, that doesn't work. It's not okay. It's not enough to just put it make it as a const, because it will go like, I see what you did there. I'm just gonna remove that const for you, and that is going to eliminate the fix completely. So that's not enough. We need to have it as a variable. So we actually create a place in memory for it. And Zig is cranky. Local variable is never mutated. So what we need to do is this. That's the sort of entire bug fix right there. Zig may choose to copy and pass by value, or pass by reference, whichever way Zig decides will be faster. Exactly. Exactly. That is exactly what happens, and I think that it may have decided to pass it, but I don't know why it would pass it by value here. Like, it's a boolean. It's a boolean. It's like the theoretically smallest piece of information that you can have in a computer. Why would it decide to pass it by value? That's my question. It's probably doing something fancy that is completely fine to do in Zig, but then when you combine it with C++, you get strangeness. But like I said, I've seen this issue before specifically with booleans, and specifically the 254 value, 245. No, 254. Sorry, 254. So one less than all ones, and that's the reason why I had that int bool thing there. I think we might be seeing some kind of small regression or something. I'm not sure if the Zig guys agree that it's a regression or this is actually how it's supposed to work, but to me this looks like a bug. So I'm probably gonna have to report this. And so let's write a comment here. Force the compiler to allocate space for the value. Otherwise, we sometimes send garbage values to C++. For example, false becomes true 254, right? Unless you can somehow represent the primitive option or result as a bit. Unrelated, but I always wondered if two-state machines can be approximated to a bit. Booleans are just the most used. How are you finding current version of Zig? I've been on Zig, on and off Zig throughout the years. Currently been using Odin. I think I'm doing something Gamedev related in Zig soon. Well, right now, right this second, I'm super confused with Zig. So you called me at a bad. Oh, there's a typo. Caught me at a bad spot here. If we're not counting the past 30 minutes or so, I'm thoroughly enjoying Zig. It has the same issues it has always had for game programmers. Things like there are no operator overloading features. The debugger is kind of meh. So, you know, you're gonna have to live with those, but if you can live with those, then yeah, I think it's excellent, absolutely. Choose Odin. I'm definitely not biased. Yeah, mine Bill is a resident Odin fan. Every community should have one of those, absolutely. Odin is not a bad language at all, especially for game dev. I think Odin is kind of unique in the sense that they vendor so many of their you know, packages that are helpful for game developers. That yeah, I think it's probably a very good choice. Okay, let's rename the stream back here. What did I call it? Something with cheeseburgers. Can I has code hot reloading? To bait you all. Of course. Yeah. But anyway, this was interesting. This was an interesting find. I'm gonna have to ask the Zig guys, hey, is this a bug or is this me being bad at my job again? To be fair, operator overloading is kind of controversial in the modern day. Odin, for example, also has no operator overloading, but has whistling. Some people will just say make a function. Some people will say that, yeah. Some people will say HLSL, you know, does well without operator overloading, and you just use free functions. But those people don't remember that HLSL has vector types with operator overloading, or operators built right in. So that's that. But I mean, it does make your math look kind of distinct, shall we say? Should we look at some math heavy code? What do we have? Maybe the drive line has something interesting. Driveline.zig. We have some math heavy stuff here. It's actually pretty old code here, so I'm not sure we have like a whole lot of. Yeah, we do have some. Yeah, things like this. Like you need to use like sub instead of minus. Of course, some people think that you should just have freestanding, so it should be this instead, and then you should have something like basis math sub, or perhaps in this case basis vec3 sub, and then that which I think you can actually already do with this, right? I think you can do that, can't you? That's supposed to be a math, by the way. Math vec3. There we go. So I guess that's kind of neat in the sense with these functions, because you can do kind of like position sub position, but you can also do sub position position with the same code. Works fine. So if we have, you know, const, this is actually like live code now. So this would be I plus 1. That would be that guy. No, that would be that guy actually. Here we go. That's that guy. And then we have I is the other one. Or we already have something called I. Let's just make it large I. That would be large I plus 1. And then we can copy that thing in there. You can do the same thing here. So we have like some result. So 0 would be I plus 1 sub. And that's supposed to be position. Like so. I plus 1 sub I. That's one way of doing it. That's almost kind of like doing, you know, I plus 1 minus I. That's how I like to write my game math code. But then with the same math, you can also have basis math vec3 sub I plus an I. Right, that also works. What is it complaining about? Unused local constants. Oh, yeah, it needs to be large I, capital I. You know, that's that sort of thing. Because of course this sub is just like, it takes a self parameter and then an other parameter, and then it does the math. But you can just use this as the sort of object-oriented this pointer, if you will, or if you want. So yeah, there's a lot of just like preference in this discussion. Be sure to like the stream, everyone. Exactly. Thank you 25th 420. It's an excellent thing to bring up. Okay, folks, what do you say? Should we do some hot reloading after 1 hour and almost 30 minutes? We have our beautiful fix in place. And I will need to figure out if that is supposed to be a permanent fix, or if there is actually a bug in Zig. But yeah, okay, so hot reloading the DLL for the Zig code. How in the world do we go about doing that? How in the world do we go about doing that? So, again, we have this thing. If I make a change to this means game DLL thing here, it would be nice if we would just hot load this code. We're not going to really care about the engine code. We're not going to care about any of the mods. And the exe is just a very small kind of launcher. It doesn't really have any game state or anything to hot load. But what if we could hot load the Zig code? And I don't know if that's going to work, actually. We're going to have to figure that out. But I mean, in some ways, I am almost uniquely well set up for doing code hot reloading. So here is a little bit of a brain dump that I did this morning. Here's a pretty nice DLL hot reloading in theory and practice. You can just search for this. if you want to find this. You can see that the address is slightly strange because this is, of course, originally from the Our Machinery blog. And Our Machinery suddenly disappeared from the face of the earth. No one really knows what happens. There's some rumors that it was some licensing thing gone bad. But regardless, this is a Machinery blog archive that has these up, because some of these are actually really good. So they bring up some like the reasons why you might want to do code hot reloading, and they even show through this beautiful GIF here doing some of that. And then, you know, some of the things that stop people from using DLL reloading are... DLL reloading is pretty straightforward in a straight C executable, where I'm not using a C executable, but I'm using a C interface between the C++ code and the Zig code. So for all intents and purposes, it is kind of like C in that sense. Long build times, well, we don't really have very long build times. We have 2 long build times currently in Zig. I'd like them to be faster, but they're kind of nice enough. Bad tooling. Visual Studio Debugger is pretty painful to use with hot reloading. Visual Studio Debugger is pretty painful to use with Zig overall, so it doesn't really matter. This is the big one, state transfer. That's the big one, and that's the thing that is going to be interesting to solve. And then some instability stuff, yeah. So if any of you have done this before, or you have like followed, I don't know, Casey Muratori or whoever does these things, I'm gonna do the simple thing where I grab all the memory, especially the heap allocated memory, and I just like keep it around, and then I feed it to the new DLL when we have that coming online. That means that like memory structure changes will actually not work with hot reloading. Here you can see that we have a SIG allocator. SIG allocations are typically pretty small. We are allocating a whole of 6.19 megabytes of memory out of 700 when we run this little level here. And so there's not a whole lot of memory in Zig, but perhaps more importantly, that memory is allocated using an allocator that we manage ourselves, which means that we can just keep that heap alive. We don't need to destroy it, even though we get rid of the DLL under it, and that should make it somewhat easy to hold on to the memory. Let's go to main. Here is main. So we can see that, okay, we can use the standard debug allocator. This is probably gonna just crash and burn if we try to do this with hot code reloading. But we have a heap allocator, and specifically we have a basis memory heap allocator. And the basis memory heap allocator just calls down into core heap alloc, which, as you can see, calls into a function pointer. This FP stands for function pointer, calls into the C++ side. So we can just completely unload the DLL. We can unload this guy here, because all of its memory is allocated here. Like every time this means game wants to allocate memory from the heap, it goes and asks a function here on the basis DLL side, hey, can I get some memory? And then it returns it back to you here. Burp. So that means that even if we just like completely remove that guy, all of the memory is still gonna live here inside of the main one. And we do all of that already. That's nice. When hot reloading, do you share memory in a pool or heap, or do you initialize an area and have the mod manage its own memory? Probably need to figure out. Okay, yeah. Okay, now we have lots of thoughts here flying around. Minebill is correct in the sense that ideally you would figure out if something changes. I'm just not gonna do that. I can't be bothered. I'm gonna follow these guys' example. Let's see. State transfer. Instead of full serialization, we do something a lot simpler. Objects are just left in memory as is. They were allocated by the old DLL, but will be freed by the new DLL. Since both DLLs use the same allocators, it works without problems. That means that you can't do state changes. You can't go and modify the layout of a struct, for example, and then hot reload and then expect it to work. That's probably just gonna crash. That's not the kind of thing that you typically use hot code reloading for, though. Instead, what you use hot code reloading for is like making small changes to like an immediate mode UI, or you tweak some gameplay values, things like that. That's where code hot reloading really shines, and where you really want that sort of like fast turnaround time. So yeah, I'm just gonna do exactly the same that these guys are doing, especially since I already do the whole heap, keeping the heap in C++ allocated memory. And so yeah, when hot reloading, do you share memory in a pool or heap, or do you initialize an area and have the mod manage its own memory? We do a little bit of everything, because of course we have these different heaps that we just looked at here. These are all heaps of different kinds. So we have things like heaps for the resources. That's typically the largest one, 300 megs. We have a generic heap, which is kind of large because like it's the generic one, so it just allocates a whole lot of different things there. These ones that are yellow have been recently used, so you can see that the physics, so physx is doing something all the time, and the network is doing something all the time. Every now and then STL allocators are used, so there's probably something happening there. And if we start driving around, you can see a whole bunch of them just light up. Actually, not with this vehicle, but if you have another one of these guys that have like audio and particle systems and things like that, like now you can see a whole bunch of things just light up and start doing things, because you have particle heaps and you have audio heaps and everything. Actually, the audio is kind of stable there. The sprinter heap is just going absolutely crazy. It's only allocated 1.44 megs, but that, like it's doing all of the audio logic, and also the particle systems. When I think hot reloading at its strongest, I think Flutter, to be honest. Basically, an executable library plus dynamic and static will combine together in a full Flutter-like runtime. Never used, but it sounds cool. Flutter is nice. Flutter is nice with its like almost immediate recompilation when you are running in the interpreted mode. Yeah, Flutter is a pretty nice example of a well-working hot reloading system. I don't exactly know how that works. As far as I know, they kind of like the Dart is compiled to like JavaScript or something like that. Or is it WebAssembly these days, maybe? But yeah, as far as I know, it's kind of like interpreted, and then when you're happy with your Flutter application and wanna deploy it, you actually build it into something more rigid, like native code or WebAssembly or whatever. I think it's probably like JavaScript or something, when you are actually iterating on it. So they have sort of like two separate runtimes. Do you store SIG function pointers across frames? In my experience, that could be quite tricky to get right when reloading the DLL. I do, yeah. I store them across frames, definitely. Specifically, we have a few of them. I'm not sure it's going to be super tricky, but it is going to be a little bit of work. That is kind of how I see it. So if we look at like interop, I think it is like physics maybe. That's probably called like some physics bindings. Yeah, sig physics bindings. I think this guy at least has a few function pointers. Sig raycast callback. Yes, here we go. Sig raycast callback. This is not necessarily actually across frames. I think this is probably like a blocking call. But you can see this guy has these kind of weird looking function pointer I32, int pointer, U32. I think this returns an I32 and then these are parameters. And then we have another one which is I32 and even more stuff. These are function pointers into Zig. I'm not sure actually these are across frames, but I do store some of these across frames. Probably something with triggers at least. See if we can find some trigger stuff here. Trigger. Yeah. Yep. This one. Oh, no, not that one. This one. Oh, that's not a function pointer. That's just an exported function. Yeah, we're gonna have to when we load the library, we hook up all of these things to the library. So we have this library API .zig that we already looked at. We have the propagated value bullshit that we looked at. This guy has just like a bunch of exported functions like this. So that one, for example, we should be able to find it here. There it is. We need to re-hook up all of this stuff when we have loaded the new DLL. Right? So that's one thing. But yeah, I'm pretty sure I do have some function pointers here. There might also be some in Goofy interop. Here we go. I think this has some like rendering function pointers at least. Yeah, these are all also just like exported functions. Yeah, okay, here. No, that's actually that one. I'm pretty sure I have some somewhere though. And those will need to be handled, yes. We need to basically re-initialize that stuff. Yeah. So that's gonna be fun to try to get working. Yeah, here's my NVG bindings. Can't actually find any function pointers right now. Have you ever checked out Odin? What do you think about it? Check out not the last stream, but the stream before the last stream. I do quite a bit of Odin in that. It's called something like Let's Check Out Odin and C3, something like that. Yeah, you can write Odin mods. You can write very, very simple, fundamental small pieces of Odin, and load them as mods into the game already. Exported functions should be alright, yes. But for callbacks you may need some sort of registry to update those once the module reloads. Exactly. Yes, exactly. I mean, it's essentially the same thing. Like, exporting functions are just as alright as the function pointers. The thing is that you need to hook up both of them. You need to hook up the exported functions, and you need to re-hook up the function pointers. So for example, let's actually try to find this now, because I think it's going to be a pretty good example of a system that we need to handle somehow. So if you are here in Zig, and we go to physics trigger, we can register an enter callback. We give it a trigger and we give it a callback. And then we register an exit trigger and we give it a trigger and a callback. So where are these used? First of all, interaction areas, for example. So those would be those like yellow areas you see on the ground, and then when you enter them, you can do something like start the monorail or whatever. Right, so register enter callback. We give it a method, and it's going to call this on object, or object entered when we fire the enter trigger mechanism. So this thing, what does it do? It locks a mutex, and then it has a piece of global data, and this is also something that we're gonna have to handle. Global data, yay! We're gonna have to somehow move that over or copy it over to the new DLL. That's gonna be even trickier, I tell you. So trigger callback states. I don't think I use function pointers for this actually. At least not function pointers that are sent over to the... No, it's also handled by an export function. So basically what we do here is, when we trigger this stuff, we add this callback, which is a delegate. It's a void delegate 2. 2 comes from 2 parameters, and void comes from it returning void. We register that into and put it into a hash map, I think. Call state hash map, yes, hash map U64 to trigger state callback. This guy, and that's it. That's all we need to do, really. And then when something is actually when something is actually triggered there, the C++ code simply calls this physics on trigger event enter event, and then it finds that and goes through here and goes like, okay, I need to find the thing now. Get by the trigger actor int pointer. We get an entry, and then we check, okay, do we actually have a callback there, and then we call the actor. So actually the callback, which is this void delegate thingy. Oh yeah, okay, the enter one is a void delegate 1, the exit one is a void delegate 2, whatever. Anyway, the point stands. This void delegate never leaves the DLL side. However, we have this map here, callback state map, which is a hash map of this. And this stuff, of course, we do need to copy over to the new DLL. Yeah, so that's gonna be a whole interesting thing. Luckily, we can see here that we initialize it here with this init function, and we give it an allocator. And this allocator, again, is the same allocator that lives here in this basis DLL here. So it should be fine. We should just have to somehow like mem copy this stuff over to the new DLL. Hey Frozy, it has been a while indeed, yes. Have a blessed day. You too, 25th. See you maybe in an upcoming stream. Yeah, so we are not playing around with C3 nor Odin anymore. That was just a fun little side thing. Now we're back to the main tech stack. And we're finding confusing Zig bugs and all kinds of things here. It's all very exciting. Anyway, like I was saying, things like this, I typically like... I know these are not technically global data, but I kind of treat them as global data. We have these members here of this module, which is a struct, which is like sort of global data, essentially. And all the global data that we have in the SIG code, that needs to be tracked somehow. We can't just have stuff like this anymore, lying all over the code base, because we need to copy it over to the new DLL. So all of the heap allocations that this callback state map does, those should be fine, because those live in the heap, which stays alive. But this actual object doesn't stay alive. If that makes sense. So here in my list, I had some thoughts. We would have a hot reloading command line parameter to like enable this thing. And then when we actually load the DLL, where's my debug console is what I want here actually. Where are we? Can I find here? I can. Yeah, means game. Here we go. So this thing loads means game.dll, which is what we are building here in Visual Studio. And we can't do that. We can't actually load the DLL that we are building to, because then if we try to build again, it will be blocked. So what I was thinking we would do here is that when we load, let's say, means game DLL, and we know that it is set up to do hot code reloading, we would actually copy it to another name. So it would be something like, you know, rather than that, oh come on, copy the thing. Oh, we can't copy from there. Okay, well anyway, rather than it being means lib, means game with DLL, we would rename it to something like means game hot reload DLL or something. I don't exactly know. Then this is the guy that we would be loading. That means that this guy is still available for new data and code. And then when we realize that this guy has been modified, which is probably going to be a manual thing here in the beginning, but like eventually we could set up some sort of file watcher, then again it would copy this thing onto a new name. And I don't exactly know, like, do we need some sort of like running name scheme? Because that, of course, at that point this guy will be loaded. So we might have to like ping pong between, you know, this could be ping. That is what we load first. That's like step one. And then the next step is to build to means game DLL again, and then we call means game hot reload pong DLL. And then we can load both of those. We can copy over the data from this one to that one. And then we can unload that one. So then it could go back to the ping one, right? Something like that. And meanwhile, this means game DLL thing, this guy is always free to be poked at. Which version of Zig are you using, by the way? I am using probably like last week's or something. 2510. 016 dev 2510. Oh, okay, we're at 2535, so it's actually pretty recent. I think it's from last week. But yeah, it's a pretty recent one. I used to run with one from like late November actually. So it's a pretty recent thing, this update or upgrade, whatever. Alrighty then, let's remove all of that. I hope that makes sense. So copy DLL to another and load that. That's what that means. And then figure out which part of the startup sequence we have to run on hot reload. Well, we already talked about the fact that we're gonna have to rerun those rehook up those export functions and run the bind functions. Yeah, at least the function pointers have to be hooked up in C++, and the bind functions have to be called from C++ to SIG. And then how do we handle global variables in SIG? Well, that's basically like this thing here. This map here, for example, or this boolean. So what I was thinking is that we would have all of our global data in one struct per library. So here we have the entire game project here is sort of like distributed or spread over a number of libraries. We have means, which is the game itself. We have means lib, which is the library that contains a whole bunch of things that both the game and the mods can use. We have the main game engine, and then we have a bunch of libraries here that do different things. And so I was thinking that like each of these libraries, each of these top level things here would get their own struct of global data, and all the global data needs to be added to that one rather than just sprinkled randomly as these kinds of like variables are here, because then we can actually just mem copy those, or if we allocate them on the heap, we don't have to do anything. Then we just need to set up the pointer again. I saw they added some new stuff for dependencies in build system. Ah, okay. That's cool. I haven't looked at that since yesterday. I did, however, go in and add the std.io stuff everywhere. So almost everything now in the code base, not quite, but most things that accept an allocator like this, they also now accept a standard IO object. For example, we need it here for the mutexes. You can trigger a mutex lock and then an unlock. You need the IO system for that. So that's a new thing. That's a thing that came with yesterday's upgrade to the newest update, I should say, to the newest SIG version. Yeah. So you're using new async? No, I'm not doing any async stuff. I probably could. I don't know exactly the state of that, what that would be, and how well that works. But no, I'm not doing any async stuff. The thing with the I/O is that you don't need it just for the async stuff. You need it for every kind of input-output operation. So, for example, save game data. Write to file and read from file. You need to pass it the I/O to like create file and open file. They all need an I/O these days. So I need to pass an I/O here in the init to this type as well, just so that it can read and write stuff. But no, I'm not doing any async. That could be kind of interesting to do though at some point, but no, not yet. Also not sure the state of that on Windows. If anyone has any experience with that, do let me know. It might be kind of interesting to try it out. Alrighty then. Cool. This took way longer than I expected, getting actually like properly started with this hot code reloading thing. So I'm gonna take a quick break, and then I'm gonna be back. It's gonna be a somewhat long stream, I think. But I'm gonna go make myself a celebratory cup of coffee because we managed to figure out that, or not figure out, but managed to work around that SIG bug from the beginning of the stream. So let's put on a quick break visual, and I will be back in probably about 10 minutes, and then we'll get started with the hot reloading stuff. Alrighty, hello, hello. We are back. Oh. Looks like Loris Crow just joined our Discord. Yeah, he didn't join it all the way though. Unfortunately. You should, by the way, you should all join our Discord. You can play the game. Right now, if you want to. I was hoping I could lure him into actually joining our stream here, and I could show him this bug that I found. But Okay, well, I guess we'll see. See if that happens. I guess we'll see if that happens. But okay. Let's keep going. So, what should we start with? I think we should have some way of just like kicking off this entire hot reloading business some way. And I think we also want to have some sort of just menu item here in the top where you could actually like reload the thing manually. File watchers are kind of notoriously fiddly. But I think I will eventually want to have a sort of a file watcher going so that it will hot reload it automatically if you rebuild the DLL. But for the time being, let's not do that. Let's just have a manual like reload code thing. For example, here in the app. I think that's reasonable. So let's go with that. I'm going to shut that down. And we need to somehow figure out how to do this. So I was thinking we would have a command line argument or parameter here. So we could do something like hot reload true. Oh, it would be dash hot reload true to sort of stick with my convention here. So let's close some of these things down. And look at what we have here. So we have dynamic library. This is really, really old code. I don't really like the way this is written, but I'm not going to rewrite it now. I think this is probably fine for now. The way you create one of these things is you give it a name. And then, based on the name, it kind of figures out, okay, I'm gonna load the, okay, yeah, it constructs the path based on the name. And I think this guy just loads it directly from the executable directory, right? So that's where it searches for that function. The name of the module. This can be either a library module or an executable module. If the special module is an executable module, static imports are not loaded. If the string specifies a full path, the function searches only for that path of the module. If the string specifies a relative path or a module without a path, the function uses a standard strategy to find the module. Yeah, I'm pretty sure that it looks like in the exe folder first, and then try some other ones. So full name is not really full name, it's just like name and extension. And then if we are loading a debug one, then it's _d and DLL. Then you can have load by path, in which case it just treats it as the thing is like a full path. This is what I really don't like about this. Like, I don't know why I did it like this some like 10-15 years ago. Rather than just giving it the path and loading it that way always. But anyway, that's how it works currently. So you just give it a name, and that's why we can do main cpp. And if we go down here we have a Zig library name is means game, and that means that it's means game.dll if we are in release mode, and it's means game _d.dll if we are in debug mode. It's a convention that I took from Ogre originally. For some reason, because, well, I used to use Ogre as the graphics renderer at the time. Anyway, so that's how we load these dynamic libraries. And if we go and have a look here in application, CPP, dynamic library, yes. We create a vector of pointers to them, and we delete the vector of pointers to them. Here we load the plugins. The plugins are things like the physics engine and the graphics API, things like that. Load dynamic library. Unload dynamic library. And here we go. This is the part where we actually load the Zig library. So load Zig app library, and we use that Zig library name that we just looked at, and then we get a library out of that. Yep. And what are the conditions for calling this guy in the first place? Right. If we have a Zig library name that's not empty, then we call it. Because of course you can use this engine without loading any Zig at all. You can write a purely C++ game with this if you want to, and this stuff is just removed. So that's okay. So somehow here we would like to actually do the renaming of that stuff. If we are loading this with hot reload enabled on, which should probably only be available in like debug builds, then we do like the whole renaming of the library here. And rather than passing Zig library name here, we pass the renamed stuff. Right. So let's maybe actually start by creating just a boolean here. Zig app library is right here, right? So let's have a boolean hot reload Zig app library enabled. When we initialize that to false, so basically for this thing to become true, we need to run it. To run the game in a development build, we need to pass it this hot reload command line parameter, and yeah, I guess that's it. Those are the two conditions that need to be fulfilled. So load Zig app library. Yeah. Let's maybe add a boolean parameter there. Hot reload. So that does not mean that we have that flag enabled yet. It basically just means that we would like to have it. And so this guy gets set by this thing if we have actually sort of like let's see, where was the thing? Oh, there it is. If we have this command line parameter, which is hot reload, and its value is true, hot reload, right? And then we want to wrap it in something like that, yeah. So if we are not defining basis config final, which is like a shipping build, then we have the option to enable hot reloading. Otherwise, hot reloading will be hard-codedly false in the shipping builds. And then this guy needs to do some gymnastics here if we are actually attempting to enable hot reload support. Let's copy all of that inside of it for now. I'm sure we're gonna have to split some of this stuff up actually. So what do we do currently? We load the dynamic library, we just looked at that. Then we call load native phase 1 and load native phase 2 on the app library. So this is a dynamic library, the thing that we load off the disk. But then we pass that to something called a SIG app library, or SIG library actually is the type here, SIG library. And the SIG library is a type that it does a whole lot of stuff, arguably perhaps a little too much, because it also handles the WASM library support. So it has all of this, all the C interface that we've looked at many times. And it handles the communication between the C++ and the SIG side. And here we have a comment. Loading a SIG library is split into 2 phases. After phase 1, simple things like checking version numbers can be done. Phase 2 hooks up the APIs and binds the types and all of that. And we can see exactly this thing here. We are doing the load native phase 1, then we do a bunch of version checks, and then once we know that, okay, we're gonna be able to actually find what we are looking for, at least we should be, if it doesn't lie about its version numbers, then we can load phase 2. Phase 2 is the thing that hooks up all of these functions. So this is the thing that we need to do after each hot reload, or within each hot reload operation, because we need to hook up these same exported functions. Plus a whole bunch more, probably. But that's something that we need to do every time. This one, I don't think we need to do more than once, but we probably need to have like a slightly different version of this thing. Because here we are actually passing the dynamic library to the SIG library. Right? Load native specifically means we are not loading WASM. Because we have load native phase 1, load native phase 2, and then load WAMR phase 1, load WAMR phase 2. WAMR, of course, being the WASM runtime that we are using. So, we probably need to tell it here if we are actually hot reloading something here as well. Or maybe we will just have... I don't exactly know what this should look like. Because we're passing it the new library. But it can't overwrite the old library directly, right? That's not okay. So what do we do? Maybe we'll just quite simply have a function here called hot reload native. And we'll give it the new library like this. I'm gonna even call that new library. Right. That should be fine. And initially when we load a library, we call this load native phase 1. This guy shouldn't really need to know whether this thing has hot reload support or not, because the hot reload, to be able to do hot reload, we need to rename the DLL file like we already spoke about. But that stuff has already been done by the time we go here, because we have this dynamic library pointer, right? So this hot reload native function probably should go here after that, but before the WASM stuff, like so. And this guy will like do the whole shebang. It will throw away the old library and initialize the new one, or rather in the other order. Initialize the new one, copy stuff over, and then throw away the old one. So maybe we'll write some comments here about what we need to do here. So initialize the new library, and that might mean creating a new C API, right? Because we might need like 2 of these C APIs to actually actually be able to communicate with both libraries at the same time. This is not relevant. That's not relevant. That's kind of not relevant either. Yeah, I think we're gonna make a new C API here as the first thing. So make a new C API. Initialize the new C API with the new library. Copy over global data from old library to new, and that's actually something that we might have to write a little bit of code. We might have to have like a function, an exported function in the library to be able to do that, so we could like memcopy stuff over. Right, and then assign the library pointer to point to the new library. There might be some other stuff involved with that as well. And then unload the old library. Except that probably is actually done outside of the Zig library thing. Yeah, so let's maybe do it like this. Like step 5 is like unloading of the old library is done outside of the Zig library type. Let's see. Hi, what's going on today? How are you today? I'm pretty good. I'm pretty good. Let's see, I have a typo here. Initialize. I'm pretty good. Trying my damnedest to get hot reloading working. Encountering some Zig bugs in the process. And generally making a fool of myself. But other than that, yeah, not bad, not bad. So that would be that. Alright. So we have a native dynamic library member here. I don't think we need another one for the phase where we have 2, because I think actually all of that stuff is going to happen inside this function. I think when we exit from that function, it should all be basically done, I think. And the only thing we need to do then is unload the old library, like with this. Sounds fun to fix. Yeah, I don't exactly know how to, if you're talking about the Zig bugs, I don't exactly know what those things are yet. So I'm gonna have to ask the Zig guys later on. Let's see if we can get Loris to join our stream here and actually have a look at one of the bugs that we found somehow. Let's see, can we build the game? We can build the game, but we can't run it. What? See Zig API init library. Zig API was null pointer. What? What did we do? Probably something here, right? Oh yeah. Yeah, we're running this now, aren't we? This is printf. Hello. We should see that in the output. I think we're quite simply just skipping. Yeah. We're just skipping the loading of the library currently. That's completely fine. We just take away our command line parameter here. We should be able to run the game again. All right, here we go. Yep. All right, we have our outputs there still. That's fine. I can remove them later. All right. Well, I don't think I'm gonna bother Loris right now. I can check later on the Zig channels. Rightio. So we have two paths. Either we do the hot reloading or we don't. A lot of this stuff is actually going to be the same, whether we do the hot reloading or not. We are, however, going to want to do the renaming here. So this stuff probably, like if we put this here, null pointer, and then we quite simply initialize this thusly, right? And this guy actually, yeah, that guy stays inside of there. That's fine. So here we need to do the renaming of the thing, right? So we need to have that ping pong system going. So let's do mhot reload zig app ping. And it should be actually true from the very beginning. So here at the very end of this thing we do ping is not ping. And if ping is not ping, then it's pong. So we're gonna do like a ping pong renaming scheme here to make sure that we can actually write to the DLL. It's never gonna be blocked by the game itself. And yeah, here I guess, you know, at that point it's gonna be enabled quite simply. So here we want to do the, you know, to do rename the DLL to the ping pong version of it and load. So basically we want to copy it. We want to construct the file name somehow and we want to copy it. So we have something called file system utility. Can we get the exe folder from here? We can get the working folder, but I'm not sure we really want to have the working folder. Well, I mean, that could be, yeah. That could, of course, be one thing that we could do. I don't have a function here to get the exe folder, because the working folder is not the same as the exe folder. That's a different thing. Here we have executable folder. Okay, does that actually happen before that? That would be handy. Okay, it does not, but we can actually probably move that upwards a little bit. Yeah, because we need the executable folder here for stuff. Yep. So let's just move this upwards a little bit. To above this thing, right? Executable folder is there. So with that change, we want to change that one comment here. Set the working folder to a writable one. And here we can see that, okay, we're actually getting the working folder, and that is the executable folder, because the process starts with the working folder as the executable folder. So that's fine. We quite soon change it though. So let's add here a string parameter executable folder, like so. Use it here as well. I think we can actually just remove this guy. This was a test that I had. You can see that it's like if-deft. If we have WASM support, we can do this, but it's just commented out. This was a test where I tried if I could actually like run the entire game as a WASM module, and it turns out that I actually could, but it was mostly just for testing. So I'm just gonna remove all of that. That's fine. And then let's construct some paths here. So if we do a hot reload, we do string original is executable folder plus m application params zig library name. Plus missing there as well. That's the original one, and then I'm let's think about this. Yes, that would be source, and this would be destination, dest. So if it was like originally something like C game means game.dll, we wanna turn it into something like means game hot reload ping or pong. So that would be ping.dll or pong.dll. Like that. And the .dll stuff we don't really have to care about. That's handled by the dynamic library class. Of course, if this was like on a Mac, this would be like dlib, and if it's on Linux, it would be so. So we don't actually give the extension there. We just need to handle the name. So if if this, then we do dest append probably like hot reload ping. Maybe it should be with the capital R. Else hot reload pong. If what I'm doing here doesn't make any sense to you, feel free to ask. I explained this earlier, but it might be kind of confusing, I guess. Let's write a comment here. Don't load the original DLL. Instead, copy it to a special hot reloadable file, which gets two distinct names on which distinct names. Gets assigned one of two distinct names each time we hot reload the library. Ping or pong, right? Something like that. And this logic actually probably would need to be moved into another function, because we're not going to be calling this load zig app library all the time. We're going to be calling some other function which is like hot reload zig app library, and this function, this thing that copies the thing from source to dest. So we can do file system utility copy file from source to destination. This needs to actually be used in both. Oh, could I use the... Yeah, move the chat. Yeah, I can move the chat. Let's move the chat. Let's move the chat over here, maybe. Maybe that's a better place for the chat anyway. My code tends to be on the left side anyway, so that's probably a good thing to do. Alrighty then. And now, once we've done this, we can actually reload the thing. Okay, so I'm gonna make another function here. This is the private section or the protected section. Yes. Okay. Good. Load zig app library. Cool. So, what we will do is this. We're gonna create a function that does this thing, and it basically generates a hot reloadable DLL path for us, right? That's what we're interested in here. This should be fine. We're inside basis. So generate hot reloadable zig lib zig, I don't know, app library path. Let's be explicit here and write out the whole thing. So it would be something like this. Or let's see, maybe that's not, because it also copies the thing. So let's have it like make zig app library hot reloadable, right? That would be the name of the function, and then it does all of this, all of that. Most executable folder. Okay, I'm gonna pass it. Don't you worry. And then we're gonna return the destination. Right? Then we're gonna return the destination file path. This now goes into the executable folder as well. We could make it load it from the app data folder, but nah, I don't think we really need to do that. Okay. So now we can instead then do string path make Zig app library hot reloadable. I'm going to pass it the executable folder, and we're going to do lib equals load dynamic library path. Yeah, that's not it. It's a dynamic library. There we go. So now if we do this, I think it should already work. We need to enable that. We should be able to load the game. Oh, there's an error. Why is there an error? Oh, it's because it wants the executable path as well. Executable folder. Yeah. So we should see it actually load a different DLL than the one that we actually built, right? And it always does the copy, which is important because if you have like old stale ping pong versions there, it's important that you always make the copy before trying to load one of them. So let's see if that happens. Failed to load Misgame. Yeah. Loading library failed. Huh. Why did it fail? But it did not succeed with the copy. Let's have a look-see. So build, release, means game. Evidently it did not do the thing correctly, so let's put a basis optimize off here so we can debug this a bit better. And let's see. Okay, so what are we doing? Oh, okay. Yeah, I know what the problem is here. Yeah, that's not a path. It's not a path. So we need to essentially do like the same thing we do here inside of the dynamic library. This thing. We need to append either the just DLL or the underscore d.dll to the end there. I'm gonna move this up off to the side here so I can see what I'm doing. So basically, like if we are in debug mode, we're gonna do something. If we're not in debug mode, I'm gonna do something else. So this would be underscore d DLL. Right. Yeah, actually it's just like it's this. We only want this one. There's one line here. And the destination. And the destination is all good to be here, but then we want at the very end we want to either append underscore d DLL, or we want to just append DLL. That should be better. Let's try this. Let's put a breakpoint there and run this dude. And there's one more thing we actually still need to do, but let's check out this first. So now we have the... Yep, that looks like a valid source. We have a mix of like forward and backward slashes there. That doesn't really matter. So now we should be able to actually see this new file here. Shouldn't we? Sort by name. Means game. Means game. There's no... Oh, there's no actual copy done, is there? Oh, that's not the correct folder though. That's not the problem. That's not the correct folder though. We don't get the correct folder here in the executable folder. It's the project basis build trampoline. It's supposed to be project basis build release. Ah, okay. That's stupid. Why does that happen? I do wonder if we should just like try to get the like Windows use the Windows way of finding the exe. Get module file name. You can do this with the get module file name function. Yeah, something like this could work. Yeah, I think we're going to do this for Windows only right now, because I don't really support using these tools on any other operating system anyway. So let's move this back here, because it evidently does work there. And we can remove that. I think we can remove both of these. Pass that there. Not there either. So let's see if we can figure this out. We probably have some windows. Yep, here we go. Just do a basis basis error basically. Maybe an assert failure. Unimplemented or what? Reloading only implemented for Windows so far. Something like that, and then we can do the thing. Module file name. Let's see if we can actually do that first. Add here like an empty the string. Mm-hmm. Oh yeah, that still has that function. Or parameter. Yep. Mm-hmm. Yeah, that's what you get for copying code from Stack Overflow, missing semicolons and stuff. Of course, the like canonical way these days would be to use ChatGPT for that sort of stuff, but I don't do that. What is this? That's a white char. That's annoying. We can, however, probably use the same stuff we have here. To convert it to UTF-8 if we want to. So OS utility. Let's keep that there. Okay, let's see what we actually have just by running this and seeing what we get in this file name. To make sure that's correct first. Remember, this is a completely development time thing, so it's not really something that we really need to. It's not something that needs to be like rock solid when it comes to all of these like encodings and everything. Right, that gives us the actual name of the file. That's not really what we want. We want the name of the folder. Current directory. Are we actually calling that somewhere? Right, so the current directory is like curiously is set to something else. This is actually what I would like to do, and and the thing that I indeed do here. Get working folder, yeah, it does exactly this. The annoying thing is that the working folder, at least for a little while, doesn't seem to be the same folder as the exe file. Probably because of some Visual Studio shenanigans. So that's stupid. But okay. Okay, so are we gonna have to like do stream processing here? This is stupid. This is stupid. Because we really don't know the exe file name, nor really should we need to know that. I mean, we got the path to the exe, which is fine. This guy, but I really don't want this to have to like depend on knowing the file name, because this might be trampoline.exe, it might be traction point.exe, it might be something completely different. Currently it's trampoline, because that's like the launcher name. In packaged builds it's traction point, and this thing shouldn't really depend on that at all. So many things to solve. But okay, we can. I guess we can like get the last index of that, right? And then get all of the characters up until that, and then strip away the rest. I guess that's probably the best we can do here, annoyingly. So OS utility, convert from UTF-16 to UTF-8. That gives us a string, a stud string specifically. That's interesting. Yeah, it just gives us the path directly, exactly. Okay. I'm just gonna call that path as well, like so. OS utility must be, OS dialog. We don't have OS utility included. There we go. There we go. Okay. And then we can do UTF-8 path, find last of that, right? Or actually, it would be this, because we're on Windows here. So that gives us a size T, last / index. And then the folder path would be let's call it exe folder path, would be UTF-8 path substring from 0 to last / index. Right. Figure out the folder or the path to the folder containing the exe file. All right, let's try that. So exe folder path. Here we go. Okay. Cool. And if it's just sitting like theoretically on the D drive, it would be just D:, and then we add back one more slash there, and then it will work. Cool. Excellent. So with that out of the way, now we can do let's continue here. The source would be exe folder path, and then the library name, and then DLL. Yeah, all of that. That should be good. Except we want to have. I'm gonna do this slightly differently. I'm gonna do a string with a capital S, so we get the basis as own string type, and then we do string utility, temp format, and we give it the exe folder path, C string, and we give it the application SIG library name, also C string. And then we do %s. Let's just go with backslashes here because we are on Windows. Right, so exe folder, then we have SIG library name. So that would be another %s and then .dll. That's the source. Right there. And then we have the same thing here, except we have _d. Right. And then maybe we can do the same thing here. So we have string dest is string utility, temp format. And we do exe folder path cstr. And we do zig library name. Actually, we do the same thing here. Yeah, all of that is the same. But then, as a third parameter, we do either ping or pong, depending on this. Right. Actually, no DLL yet. So exe path, we have that one, and then we have the second one. So hot reloading ping, hot reloading pong, and then this thing can be the same. And these guys we just remove. No, actually not that. These guys can be the same. Yeah, I think that's probably good. And then once we've used this ping pong thing, we flip it. We don't want to do that here. This thing should be put up, made true here, and we can't actually load that path. That's another thing that we're gonna have to tweak and fiddle with. But anyway, let's try this out. This should now work. But then again, I said that about the last version, so who's to say? Right. So before we do any file copying, let's look at what we have here. Destination. Let's find the pointer to it. There we go. Oh, that's not good. Right, okay. Yeah, we don't want those initial backslashes there. Hey, Shugrado, welcome back. Oh, I did the copying of the file. Let's see if it worked. Yes, here we go. Okay, means game hot reload ping. Hot reload ping, and next time we call that, it would make hot reload pong. And then it goes ping pong between those two. Okay. Excellent. So that did in fact work. And then it returns this guy. And this is now a path. If we go have a look at load dynamic library, we can bring that back actually. Let's go have a look here. You see it does load. In this case, what we actually want here is to do the load by path thing. So I'm wrapping this horrible API here behind. We have some slightly newer code. Let's make a bool load by path here. Yeah, they both return bool, so we can do like bool success is. If we load by path, then we call lib.load by path, otherwise we call lib.load. And then we just do this now. That's it. Then we have a few places we need to actually do load plugins. Load by path should always be false. And here it should be false, but here it should be true. Okay, so now, if my calculations are correct, now we should be able to run the game again. But we will be able to run it by loading that ping pong file. So we should see it nicely in the output of the Visual Studio debugger. Okay. Phew. Lots of stuff to do here for this seemingly simple thing to happen. That's how it is sometimes. Okay. Yep, we can just run everything. That's cool. And now we can see here. Hey, we've loaded the means game hot reload ping file. And of course, the whole point of doing all of this is that now the game is running, and we should be able to, let's actually make sure that's the case. We should be able to run it here, and it should run and work and everything. Everything is fine. Everything is fine. We can spawn a mother, and we can spawn a scout, and everything works. And the whole point of doing that is that we are leaving this file, means game DLL, untouched. We're not loading it. We're just copying it. I can actually see here already that, like, okay, we have these PDB files. I wonder how the PDBs would be actually reacting to this sort of thing. I bet they wouldn't be reacting very well. Well, we'll see. We'll see. There's some things here that might be a little gnarly with this that we might have to figure out at a later point. Okay. So now the game loads in such a way that it doesn't block the main DLL. We can still build to it. Right. That means that we can do something like remove Zig cache here. Bloops. And now while the game is running, we can still build this. And we can see that we're making a full build of the game now, the Zig part of the game. And there we go, build succeeded, so it's not blocked. At this point we would like to have a button up here that we can click, which goes and reloads the thing. Let's make that next. Where do we actually draw that file menu? We actually draw it from Zig, is that the case? Nah, I don't think so. Oh, thanks. Thanks, Visual Assist. Oh, one second. Getting a phone call. Be right back. Alrighty then, we are back. Let's see, where do we have our... Okay, here we go. App. this is the thing that I was looking at. Let's see, is this debug overlay manager? No, it's not friend with anyone. It's not friendly with anyone. We do include the application, so I bet we probably use it somewhere though. Local server running, yeah. Okay, so what we basically want to have here is that, like, if hot reloading is enabled, if this is true, we want to actually show a hot reload option there. Let's make it a basis force in line bool is hot reloading enabled const, and just return that one. Yeah, like so. And then we also want to do here as a sort of a little bit of a hack, hot reload zig app library. Right? Yoink. And we just put it right after this guy. So we have all of this logic here in one fancy little place. Underscore methods are typically things that are like one of sort of like what do you call it? One of functionality that is like supposed to only be called from some other place of the engine that you're not supposed to call yourself. That's basically how I just denote that yeah, this is not really a public API. Don't go calling this directly, it's probably gonna just crash and burn. Okay, should we do some kind of separator? Imgu separator. I guess separator is how you create one of those like horizontal lines here in these menus. Let's try that. Yeah, okay, we actually have a commented out separator here. Blah blah blah. All right. Now then, let's create another one, and then we do imgui menu item. Oh, actually, yeah. If application is hot reloading enabled, then we do all of this. So hot reload, I don't know, zig application, I guess. Let's just call it hot reload, that's fine. I think I want that to be a capital R. That's an application H. Here we go. And just print something here. Yay. Do we use the application in many places here actually? Here's one, but it's in another function. Okay, that doesn't really matter. Let's just go with application get and then underscore hot reload zig library. We're sort of going through the singleton pointer there a couple of times, but it doesn't really matter. It's only development stuff anyway. So first of all, let's run this without the command line parameter to make sure that that the normal path, normal code path, is still working. We don't want to break that. We also shouldn't see anything here now. Exit. And if we look at the libraries that we loaded, we just loaded means game.dll normally. Cool. So hot reload true. Hey, now we have a hot reload. And if we click that, it says yay in the output. And we loaded the hot reloads. The means game hot reloading ping DLL. Okay, cool. So here is now then, of course, the place where we would start to do these interesting things. Now, if we hot reload, we need to generate another one of these paths. So let's do that. Let's new path. And then hot reload, and we give the path to the actual library, right? Like that. So it should start by loading the hot reload ping library. And then if we click that a couple of times, it should make the copies and load. Well, it doesn't load anything, but it should print the path to the other ones. So let's go to release here. We have 129 items. If we do the hot reloading, yeah, now we have 130 items. And now you can see that, okay, now we would be loading the Pong library. And if we keep doing this, now we're loading the ping library again. How about that? So here we have ping and Pong, and then of course they're exactly the same currently. Okay, so that's nice. Now then, what we need to do here is we need to load the library just the same way we did up here. So this thing, that's the first thing to do. And then to drive some of these, like load these faces here. But we actually probably want to do this internally. Yeah, I think that's how we want to do it. But we want to load the library anyway, so let's do that. Let's create a new library here that we load. We can even leave that path there. That's completely fine. So we're going to do dynamic library, new lib. And we call that new path. So let's put that in. Coolio. Then out of the Zig app library, we can get the native dynamic library. This would be now the old library, right? Old lib is there. And here we now want to do mzig app library. Mzig app library. Come on. Oh, okay. I'm just doing wrong things here. What we actually want to do is we want to call hot reload native, and we want to pass it the new library so that it can do its internal switcheroos around. And then we want to do unload dynamic library and pass it the old library, right? Something like that. Now this is going to catastrophically fail if we try to run this now, because we're not doing anything inside there. But like, yeah, it's just a linear search through the list. So let's see what actually happens if we do that now. That's probably gonna be completely bonkers. What do we do here? We don't do anything. We just have just some comments. I'm pretty sure the game is gonna crash immediately when we do this. So hot reload. We load the new library. That's fine. So now we've actually loaded both the ping library and we have loaded the pong library. Okay. And we get the old one, we do hot reload, and then we unload. And look at that. Yeah, that's not good. That's not good. Int pointer from host. We don't get like any sensible... we don't really get any sensible call stack here. What does the parallel stacks show us? So we're unloading the library, and then somehow through that we get into a case where the SIG code fails. That's interesting. I wonder if that actually has to do with the fact that we are running client and server on two different threads. So if we make sure that we don't have a server thread here, server thread false, I think we should at least be able to unload that thing, right? I think this might have to be one of those things that we run in a so-called sync point, where like the server and the client thread are locked, right? Yeah, look at that. Now we can actually unload the dynamic library. So previously the server thread was doing something on the server. Well, the server thread was doing something in the DLL, and we sort of like pulled the rug under its feet, basically. That's not good. We don't want that. Here in the asset server resource manager, if I remember correctly, there is a place where we actually sync those threads, isn't there? Maybe it's not actually here, maybe it's somewhere else. It's used for this thing though. Let me try to figure out where it was. There's a slightly confusing threading construct that allows for doing these kinds of things. Yeah, it's a thread gate. Where do we use thread gates? Oh, it is actually here, yeah. Process resource events. Yes, all right. So this method controls which threads can do the actual processing of resource events and when. If we have no server thread support, the calling thread, which needs to be the main thread, can simply call process events internal, provided there are events. Yeah, so that would be like this else case here. We just check, are we the main thread? Sure, yeah, then we just call them in a loop. If we have a server thread support, things are a bit more complicated. If this is called by the main thread, we first check if there are events available. If there are no events, we can skip the rest of the method. If there are events available, we check if the server thread is running and set up a thread gate, protecting the call to process resource events internal. So this would be like the same sort of thing that we need to protect in our hot reloading case would be actually this function here, hot reload native. Actually all of this, yeah. Pretty much all of this function. Well, at least those two. If there is a server thread running, the call to mreload resources threadgate lock will wait for the server thread to call this method and call arrive at. Yeah, arrive at is there. At this point, the main thread can continue and process the events. mread.resource thread gate unlock will open the gate and let the server thread continue. Exactly, yeah. If there's no server thread running, the client will still lock the gate, but not wait for any other threads to arrive. Exactly. So this is kind of something that we would put into like a client client update method, and then rather than having like resource events available, we would have something like hot reload scheduled. All right, and then we would do this. Again, this is on the main thread, which is the same as the client thread. So we check like, okay, is the server thread running? Yes, it is. Okay, we have one thread, otherwise we have 0. Then we do the thing. And if we are on the server thread, we call this arrive at instead. And this arrive at will hang around in this arrive at until we unlock the gate again. Yes. So it's a little confusing, but yeah, it should work perfectly fine for this as well. And so what we would want to do in that case then is have a function here in the application, which would be something like update hot reload. And if we don't have any hot reloads pending, then we just skip out. And actually calling this here we go, this hot reload zig app library, this would just set a boolean to be true. Yes, we have a hot reload pending, right? And then both the client and the server would run that, like, you know, check for hot reloads, blah blah, every update. Yeah, that should work. So that's what I'm gonna do. I'm gonna go get a glass of water because I've been yapping so much again. And then when I come back, we are going to be doing exactly that. Alrighty then, let's actually have a look here and see process resource events. Where's this called from? Because this should be called from both the client and the server somehow, shouldn't it? Right, it's called from the update of the asset server resource manager. Resource manager. So there's probably a call to update here somewhere. No? Okay, but then it's probably in host, which is the base class for both the client and the server. So let's do resource manager update. Not there either. Well, that's strange, isn't it? In that case, we will just simply put a breakpoint here and see how it actually gets there. Specifically, I'm interested in that thing. Update, yes. Okay, here we go. Application update resource manager. Update resource manager. Okay. Cool. And we do the same thing for from the main thread as well here. Is the actual main loop of the application here. The update resource manager and run server thread iteration update resource manager. That's fine. Okay, excellent. And this is actually found in application itself, so that's even better. Let's find it here in the header, update resource manager. And I'm gonna put it probably under, like inside of an if def, but let's do update hot reloading. Let's call that like sig app library hot reloading. And we want it inside of an if not def final. I don't remember the exact name of that thing, so final. Yeah, that thing. All of this code should be stripped out in the shipped builds. Coolio, we can profile it, sure, that's fine. Now, here is probably where we should put that gate. And so let's go have a look here. What was the gate? What did the gate look like? Here it is. So it's that, and it's quite simply just called a thread gate, yeah. So we probably need to include that. Yes, we do. And again, we're going to want to have it inside of that. So what is called? Basis config final. If not def basis config final. All right. Just going to put it here at the end. We call it thread gate. And then we do zig app library reload, hot reload, hot reload thread gate. It's a bit of a mouthful, but it can't be helped. This thing doesn't need to be initialized though, right? We just create it and then we use it. Yeah. So lock, unlock, and arrive at. It's actually kind of a simple thing. So, update zig app library hot reloading. We want to basically take all of this logic here. Yep. And that can be just arrive at. Good. Right, we also have the server thread support thing. Do we actually? Yeah, we just always have it here, regardless if we have server thread support or not. If you don't have server thread support, you don't really need to do any kind of gating here, but you know, it's fine. Maybe I'll move this off to the side so I can look at this code and that one simultaneously. So we're gonna have to have some sort of boolean that we set to true when we actually want to do a hot reload. So I'm gonna create it here, but then we're gonna move it to a member later on. So we'll call that m zig app library hot reload pending. Right? Just make that false. whatever. And then we're gonna copy a chunk of this stuff. Right, so what do we have? Main thread, resource events available. Yeah, we don't need to do anything like that. That's completely fine. It's quite simply if this is pending, then we do the thing, and then we set it to not be pending, right? If we're on the server thread, we don't need to do any of that stuff. In that case, we quite simply arrive at the gate, and if we don't have the server thread at all, we can just quite simply call hot reload app library. So this thing we should split, you know, the setting of the thing as being pending and doing the actual work. We need to split that into two separate pieces. Yeah, man, this is turning out to be challenging to implement, but I don't think we have any real problems here. It's just a little bit of work to actually do this. So let's make the SIG app library hot reload pending. That's fine. And maybe we actually want to move all of this stuff in here. Let's see, how many times have we rewrote engine systems from scratch? That's a good question. I don't exactly know. I mean, typically you don't really do that. You don't really write them from scratch all that often, right? You try to take what you have and make it better, rather than just rewriting things from scratch. That's false, yes. So you know, usually what I do is I look at the system and figure out the problems and try to fix those. But you know, every now and then you go like, nah, this is just bollocks. I want to write this from scratch completely. I mean, I always want to write everything from scratch, and I always think everything is bollocks. But like, you have to be kind of realistic about it. Never gonna ship anything if you keep doing that all the time. So there's that. Okay, let me try to figure out this API here. We have this hot reload Zig app library. This thing shouldn't do any of this anymore. That thing should just set m hot something pending, blah blah blah. Yes, that should be true. Right? That's all it should do. And then we have the function that does the actual thing, which we can perform, we can call something like perform hot reload SIG app library. That's why I said perform there, because I was thinking about it. So we have that thing there. And we're sort of separating the wanting to do something from actually doing it. If that makes sense. And that thing can be private, because you're not supposed to call that from elsewhere. Rightio. And then We have the thread gate, which is currently here. That would be that, and then this is the perform hot reload SIG app library business. If we don't have server thread support and we have a request pending, we can just do it, right? So we can take that away. Yep. Yeah, that should be good. I mean, this thing is a little silly that, like, if we don't have thread support, we don't really need to check this at all. If we don't have thread support, we can just check, hey, do we have any hot reload pending? And if we do, we do it. That's fine. And then we can set it back to false here. Like so. Let's assert that we actually have it pending if we end up in here. And then if someone somehow manages to call this without it being enabled, we should bark at that as well. Bulk. Something like that. Now I think we should, at least if I haven't made any mistakes here, we should be able to do this thing even though you're running with a client and a server thread. Like, of course, it won't work and it will crash because we're still unloading the DLL, but the unloading of the DLL shouldn't crash. It should only crash when it tries to do something then in the gameplay code, which, you know, is no longer there. So the problem we had previously is that we had two threads running the ZIG code, and one of the threads was unloading the DLL while the other thread was actually running that code. That's not good. Right, and then we still need to actually call this from somewhere. So let's not forget that. And it needs to be called from here. And it needs to be called from there. Yeah, that looks good. Oh, but we should wrap it in these if defs as well. Right? It should look like this, and then it should look like that. So we have that there, and we have the same thing here. These are some of the other projects that I have here. Should do the same thing. Oops. Sorry. Well, I mean, slide doesn't really run that at all. I'm gonna leave them there so we know their place, but I'm gonna comment them out because these things really don't support any sort of hot reloading anyway. That's fine. Let's keep it like that. Yeah, this should be a pretty quick build because we only need to build the games, not the actual core engine here. There we go. So now we are running with, let's see, there we go, server thread false. So now we do have a server thread, basically. And if we put a breakpoint here in this place, which actually performs the hot reload now, bloop. If we get here, we should be able to look at the threads and see that, okay, yes, the main thread is here, but importantly, the server thread should be on the arrive at call. So let's look at where are my threads. There are my threads. Where's my server thread? Which one of them? Which one of these is it? It's probably not that one. Here probably. Is it? No, that's probably a job system thread. Don't I actually have a server thread here? I think I do. Yeah, we don't have that on. Let's look at the parallel stacks. It's usually easier to find it there. What do we have? Wasabi, more Wasabi, some audio stuff. Here we go. Server thread iteration. And there we go. Okay, so it's sitting at the arrive at call, just like we wanted. Good. Yeah, I don't know why I couldn't find that in the list there. Probably because it's sitting at these addresses here. It's kind of tricky to see. It's an NT. It's one of these maybe. Nah, that's not it. D3D background thread. And that's the video decoder. Oh, there we go. That's actually not it. I get confused by that one each time. Okay, here we go. Here it is. Yeah, the address is actually different than what you can see here, isn't it? Yeah, looks like it is. I don't know why. But yeah, here we can see, okay. So we have server thread, server runner, server thread execute, run server thread iteration, and then it is sitting here at arrive at. And that means that if we go to the main thread, importantly, we should be able to run through this line here without it crashing. That means that we don't have anything poking at that, and we can. If I keep running this, it's gonna crash. Yeah, boom. Access violation, executing location. Yeah. Player controllers, it's probably gonna try to update one of the player controllers. It's the server controller. So it goes through here. Update and update. Yeah, apparently it just dies here. The player controllers have been destroyed. Okay. Okay. So, like, so far we've been essentially just writing kind of like boilerplate code for making it even possible to do this unload reload thing. And now we kind of get to the meat of it. Before we do that though, I'm gonna write a comment here what this thing actually does. So, if the client and the server are running on different threads, we need to sync them up at this point to make sure the client doesn't unload the DLL library or the DLL while the server thread is running some of its code. Right? Something like that. Seems pretty reasonable. So now then, with this out of the way, we basically have that done. We have that done. Figure out which parts of the startup sequence we have to rerun on hot reload. That would be the next thing to do. So basically, hook up all of the functions to a new C API. So Zig library here, make a new C API is the first order of business here. Let's put the header on the right. Making a new C API is the first order of business. Where does that C API live? It lives somewhere in here, I think. Does it not? Yeah, here we go. There it is. C API, or SIG C API to be exact. SIG C API is basically just a big struct of all of the function pointers that we want to hook up. So all of the function pointers to the extern functions. We want to hook up all of these, and then we want to call actually all of these bind functions. What the bind functions do is that they actually pass function pointers in the opposite direction, because these are all of the function pointers that the C++ code can call on the SIG code, or whatever language the DLL happens to be written in. But what if the SIG code wants to call C++ functions? Well, we have these bind functions which actually just like pass function pointers to the SIG side. So that if SIG wants to allocate memory, for example, it can call this heap alloc callback. And that's actually a function pointer onto something that lives on the C++ side, so it goes in both directions. And we need to do all of that with the new library. So hook up all of the function pointers and then call all of the bind functions. These guys. They're only called once on library load. And then of course all of these other ones are called at their appropriate times. But make a new C API. That's the first order of business. So, new C API. And then, at the end of this function, what we want to do is we actually want to assign that. So I want to do SIG C API old C API is SIG C API, and then at some point later down the line in this function we want to assign that, and then we want to do mem delete of the old C API. Right? But in here we need to do things. Initialize the new C API with the new library. And that's basically like, well, we've done essentially all of this. That's not relevant. That's not relevant. We don't do that yet. We do it at some point, native dynamic library. We actually want to do that as well here at some point, right? New library actually goes there. But what we really want to do is this load native phase 2. Which sort of like pairs this SIG C API with this dynamic library, but we need to probably split this up into another another function so that we can call these things and not do anything else really. Yeah, I think we're gonna do that. I'm gonna do that next. And that'll be a private function, and we can do void hook up exported functions. And we want to give it, to explicitly give it a SIG C API. And we want to explicitly give it a dynamic library. Mic library. Like that. Lib. And then go in here. And then take all of this stuff and hook it up to this function here. And then instead call this here in the load native phase 2. We want to call it with this msig C API m native dynamic library. Like so. Here we actually want to do instead that and that. Let's see, does that work? That builds at least. Oh, what? No. Because now we can do actually this. Now that we have our new C API, we can hook up exported functions to the new C API with the new library. Like so. And that should be fine. We should find, oh, I got Australian for a bit. We should find all of these exported SIG functions there as well. This will actually give us an assert failure if it can't find the address of a function there. So that should be good. Let's see if we can run all this. Yeah, there's a little bit of rebuilding to be done. Okay, let's see. I don't know why I go above the terrain there, doesn't make any difference. Okay, so yay, we can do that. And now we have in this new C API, which of course, like, we should probably make it so that we can debug this. I'm gonna do basis optimize off here as well. Hot reload. And now we can see that, yes, okay, cool. So now we have means game hot reload ping. Isn't that actually supposed to be Pong at this point? Name. It is Pong. Are these to be trusted though? I don't know. Yeah, because we're not doing the mods because this is not a mod. We're reloading the actual game code here. I'm kind of confused though because I think that should be Pong and not Ping. We're actually running with the Ping library and we want to switch to the Pong library. Right, so the handle here is 7887437. Oh, but we have the same handle for them. That's not good. Yeah, that's not good. Are we somehow? Is it Windows trolling me here and loading it? Somehow figuring that you're loading the same library twice. Let me just not do it the second time, or do I actually have a bug here? Let's see. Let's put a breakpoint here on the return dist. And did we have the optimize off here? Yes, we do. Okay, good. Then we need dynamic library probably still. Dynamic library. Because we're basically getting the same handle there, and that's not good. We can't do that. We have the same handle for both of those. Both of those libraries. That's gonna result in some pretty horrendous things down the line. So we get a handle. The handle's value is... Oh, that's unused. Okay. That's unused. So maybe that doesn't actually matter. Let's go have a look. What does the handle look like? Oh, okay. Well, what is this handle then? Come on. H module. Okay. It's just something. It's something. Is it? Okay, it is a struct, and it has an unused integer. Okay, that's a bit weird. I don't exactly know how to interpret that, but okay. Anyway, we go in here and we load the library. The library has a handle. You can actually see here means game hot reloading ping.dll. So that's the address, I guess. Is that like a starting address of the library or something? I don't actually know. Let's store that there. So that's the ping library. And then we'll go into the game and we'll load the Pong library. Somewhere. Here we go. Right. That's the Pong one. Yes. Yes. We have that, but do we have the same address? We do not. Okay, that's good. And that also says Pong there in this little pop-up here. So I'm guessing we're loading the libraries just fine. 2 of them, even though we're doing essentially the same thing. Now then, we go in here, and we have the new library, and that is the Pong one. We can see Pong there, yes. So now then, if that is the new library, why does it say that we get the ping one? That's strange. Well, we should be able to compare the new and old C APIs. So let's add a watch for that one, and let's add a watch for this one. I'm gonna copy all of that all the way to there. That's all of the ping ones. Actually the Pong ones, because we have the new ones and then we have the old ones. So here we have the ping ones on the right. Okay, and yes, we can indeed see that the addresses are different for all of these functions. So that's basically what I wanted to see. I don't know why it says ping here. Well, this is not, in fact, this is the here. I don't know why it says ping here. There's the new library. This is the old one. It says ping here everywhere for some reason. I think that's just Microsoft's debugger going a bit crazy. Oh yeah, this should be Pong, this should be ping, and the important bit here is that these function pointers are actually different. Okay. Coolio. Okay, we made it a bit further, we made it a bit forward. I need to have a quick toilet break here, but before we do that, let's see what the next step is then. So figure out which part of the startup sequence we have to run on hot reload. I think we will have to probably run some of these Zig functions from the library here to set it up. So things like basis init. But I'm not exactly sure, because what basis init does here is it actually goes in and stores some of these pointers in a global variable. So like at the very start of the stream, I said that we're gonna probably have to reorganize our global data in such a way that we can actually just, well, not really have any global data, if I'm being honest here. Instead, we will have a struct where we can put global data. We have a better sort of handle on where that memory actually is. We might want to put it on the heap even. So I'm not sure we really have to do anything here, but we might have to. But yeah, I think the next step realistically here in our journey towards hot reloaded goodness is to handle the global variables somehow. I start thinking about that, because the next thing we could do here then, after we've done this, so this would be like copy over the global data from the old lib to the new, and that means like, is it on the heap? Just set the pointers. Is it actual global data? Do a mem copy. Like those are our two options. Either we store it on the heap, and then we don't need to copy anything, we just set the pointer, or if it's actual global data that can be, you know, copied from one place to another, then we're gonna have to have some sort of function that like facilitates that and initiates that. After that, I think we probably want to do this, or maybe we want to do it like that. Actually, I think we assign the native library before we assign the SIG API up here. Yeah, first native library, then SIG API. So let's do the same order. Then we can delete the old C API. So we've done that. Initialize the new C API with the new library. That's kind of done, but also kind of in progress. Copy over global data from the old library, assign the library point to new library. We've done most of that stuff. Let's do like here. Any additional initialization needed on the new library. You know, besides global data. If there is, then we should do it there, and then after that we should probably do the global data. I don't know, maybe the order is different. This is flipped, actually. But yeah. I think like this is actually like, this is all that is left. I say all in like air quotes here because it is probably going to be the most complicated part of all of this. But essentially it is all that is left because we now have the exported functions hooked up. The heap is still there, it hasn't gone anywhere. And when we assign these two things here to the new library and new C API, then it should just work. And then we delete that. Yeah. Yep, I think that's how it is. But anyway, quick break, and I'll be back in a little bit. Alrighty then. We are back. And we will keep doing this for a little while longer. I think I can go basically like 45 minutes or something. And that should round it up to a nice 5-hour stream. Of course, we spent like an hour and a half in the beginning looking at other bugs. But sometimes that's how it is. Okay. So, I think my next thing here is to kind of spec out and try out some of these ideas of how we could actually collect all of the global data for one of these libraries in one place, and try to sort of come up with some ideas of how we could tackle this. I'm not exactly sure how this is going to work, but basically we can do something like search for var g, and we can see that, okay, yeah, we have a whole bunch of it actually. Okay, some of these are not really what I'm looking for. Here we have like var game state, that sort of thing. That's not actually global data, and neither is this actually, because like this is in SIG, so you could essentially like instantiate multiple of this this module here, this file. But basically what I've kind of been treating as if it was global data is these things that have like var and then g for global and then some name. So we can see that we have quite a few of these actually. I think most of them are in the game, but we do have a few of them in bases as well. So the game engine, and we have a few of them here in these libraries. That's SIG standard library, so we don't need to worry about that. But we do have a few of them in Goofy, that's the UI library. We have a few of them in VHL, that's the vehicle helper library. And we have a few of them here in bases. And so basically we need to figure out a way to create a struct for bases, which contains all of this stuff. And, well, almost all of it anyway. Here's something that we really probably don't need to concern ourselves with. WASM temp memory buffer. But most of this stuff is something that we actually want to move over from one DLL to the next. So for example, here are the factory interface pointers. It's definitely something we want to bring over. Yeah, we have a few places where we're actually storing like the I/O interface here, and it kind of you know, brings to mind the idea that, okay, we kind of only have one of these guys, so it kind of simplifies things a little bit if we actually truly make this global data in the sense that, like, we don't really store variables like this just on a file level. Instead, you store them in this struct that will be handed to this SIG file somehow, and where it can store data. Then we only need one of these I/O interfaces there, because it will be shared between all of them, of course. Same with the allocator. It's typically what you actually want is the allocator, just, you know, a readily available allocator to use. It's going to be the same thing. What do we have here? Free camera controller. Yeah, all right. But yeah, how would this thing actually be like? Where would the global data be stored? I think as a pretty easy to test version, we could just use the heap for it. Put it on the heap. The heap is alive between unloading and reloading the new one. Or shall we say the heap stays alive over the course of a hot reload operation. Which means that we don't really have to do anything, we just have to get the pointer. Patch in the pointer for the new one. And that means that, okay, if we have something like bases, can maybe go with the most complicated one directly, because I think it should be fine. If we create here a new file and we call this global data.zig, quite simply. We can then instantiate one of these guys, right? And we can put all of our global data here in this one place. And that means that we can allocate it on the heap, and we can essentially treat it as just normal global data, if that makes sense. Move it over there. So if we go back here, yeah, like I said, we don't really want to concern ourselves with this WASM temp memory buffer. It can be just whatever it is. So I'm going to bring these guys over. Actually, before we do anything, let's do... Yeah, we want basically those two there. So bases and stud. I'm gonna need those for basically all of the global data. So these two come from... This is not going to be the final layout of the file necessarily, but I'm just like collecting things here. So these two come from components.zig. Then we have physics scene. Physics scene has 4 pieces of global data. Physics scene.zig. Collision callback list, what is that? That's one of those. Let's bring that over as well. What is that? It's one of those. Just things just keep going and going. Okay, we have collision data. Collision data probably has collision points. So we basically need like all of this stuff. I need to bring over. Physics shape pointer, that would be... Okay, we have to declare a few things here. We do vec3 is basis math vec3, right? But okay, this is stupid, as I'm sure you can already see. This is getting ridiculous. So how do we do this instead of doing it like this? Instead of doing it like this, we could maybe have a convention here for how we name these things. So if we have a global data struct in here, and then we just put that stuff in there. And then we have a pointer to that. So we have a var. Actually, like, let me think about this. So this is global data, and this is in physics scene. So that would be like G physics scene. Basis physics scene global data, right? Something like that. Right? So now we have that stuff there. And then here on the top level of this stuff, we need to I need to do like global data is import global data sig this way, and then we could do basis global data. Oh, nothing is public here, is it? Right? Yeah. Pub var. Physics scene. You know, IO, GIO, whatever it is. Oh, these need to be public as well, do they? GIO is IO. Something like that. I mean, this is not really reasonable to work like this, but I'm just like trying things out here. To make sort of everything. Jesus, we have many of these things. It's used all over the place. Like that. Can we now actually get GIO? We don't get auto completion for that for some reason, but okay. Yeah, that's something that we could do. Like, I would like to have the struct that actually specifies what this physics scene needs to be right here in the physics scene, and then we just have like a member of it like this, right? And then we wouldn't actually do that. We would do something more like here in the main file. We would actually do like you know, const global data or basis global data is basis means allocator create basis global data like that. Right. Catch panic out of memory, whatever. Something like that. And then we would have a global data pointer here that we can store somewhere. And then when we do the hot reload, the only thing we need to do is actually just rehook this pointer, right? So that's one pointer to do per sort of library like this. That seems kind of reasonable to do. In my opinion. Let's read through, let's have a look here at this. Yeah, not that, but no, not that either. But this one here. So state transfer. And if you weren't here before, this is the DLL hot reloading in theory and practice from the nowadays gone from the internet Our Machinery blog. And state transfer is specifically this idea of like, how do you take the state from the old library and somehow transfer it over to the new library. Global data, among other things. So, state transfer can be done with complete serialization, serialize all the objects from the old DLL and deserialize them with the new one. This is arguably the right way to do it, since in theory it will work for any kind of change, even changing the memory layout of objects. If you already have a reflection system, then maybe you can do serialization almost for free, provided all your internal objects are also part of the reflection system. And this could be the right path to take. Yeah, well, we don't have complete serialization, and neither did these guys, apparently. But yeah, I don't want to do that. Note though that you also need a handle system for accessing objects, since when you deserialize them, memory location will be different. Exactly. In our case, we don't use reflection, and implementing serialization of everything would be a lot of work. We also use direct pointers to objects and data, which means they cannot be relocated. But fortunately, it's not that often we actually change the memory layout and size of objects, so we're okay with hot reloading breaking for those cases. Yeah, me too. Me too, essentially. Hot reloading is mostly just for changing values, changing logic, not really changing the layout of the memory. Changing values in the code, that is, like hard coding UI values or things like that, and tweaking gameplay. For that, it's super neat. Instead of full serialization, we do something a lot simpler. Often objects are just left in memory as is. They were allocated by the old DLL, but will be freed by the new DLL. Since both DLLs use the same allocator, this works without problems. That's the same thing for me. Global static data for the plugin, which includes the list of active objects. Remember, we need the list to patch the method pointers, are stored in a single struct. Okay. This is kind of the idea that I have as well. So, to say this shorter, is global static data is stored in a single struct. A pointer to this data is stored in the plugin API. When we reload the plugin, we simply memcopy the data from the old state to the new state. Yeah. Yeah, that's the idea of wrapping it in a struct rather than having it just sprinkled around the code base, is exactly this thing, that if you have it in a struct, you know the size of the struct, you know the layout of the struct. And you can memcopy it, or if you have it on the stack, the heap, you don't even need to do that, right? Note that this works well even if the state contains pointers to heap allocated objects. Those objects will continue to live in the heap, and we will eventually free them when the new DLL shuts down. Contrast this with serialization, with a serialization solution. Full serialization would require us to serialize not only the object itself, but also all the other objects that it references. The objects that those objects reference, etc. Yeah. Exactly. Note that in order to do the state transfer this way, we need to have both the old DLL and new DLL loaded in memory simultaneously, so we can copy data between them. Thus we need to do DLL reload in this order. Load new DLL, copy data, unload old DLL. That is exactly what we're doing. So we're loading the new DLL even before we get here. And then we copy the data, that's like this thing basically. Getting rid of some stuff here, and then we unload the DLL after this. That's fine. Should be an application. Here we go. Yeah. Yeah, you don't need to search. So load DLL, copy data, unload. Yes. Instability. We're not a big fan. We're not a big team at our machinery, and all of us. We're not a big team at our machinery, and all of us are committed to do hot reloading. So stability of that path is not a big concern for us. If that's not the case for you, maybe you can add hot reloading to your test suite. Yeah. Yeah, that is the thing. Like, if you have something like this, then you kind of need to use it. Otherwise, it's gonna bit rot away. 2017. It's almost 10 years ago. How time flies. Okay, but it seems like I'm on the right path here with wrapping the global data in a struct. It doesn't really require us to put it on the heap or anything like that. We can still keep it here as true global data if we want to. But it needs to be stored in a struct so that we can copy it. That's the important part. And how exactly that is to be done, I think takes some tinkering and thinking how that is to be done, because we don't want to complicate the code like necessarily. This is just absolutely crazy now, but we can mitigate some of the craziness here if we do this. Like we go up here maybe, and then we do like GD for global data, and then we assign that to that. And then let's see. Next thing. Then we can just do GD like this everywhere. Not there though. But all the other places can be global data dot that, right? And then you have the global data struct here. So that could be one thing. Or maybe just, I don't know, maybe just G. I kind of like this because, oh, that's not what I wanted to remove. Because then the usage is almost the same as before. Like we can just take those away there. Bloops. So now we just have, rather than just have G IO, you have G dot and then IO, and then I would probably do something like this rather than having them be capital letters. Oh. What did I do? That's not IO, it's supposed to be the name. Yeah, I think something like this might actually be a pretty decent version of this. So if we have a look at the physics C in here, like the way this changes the syntax is from having GIO, it's G.io. But I think this is not exactly how it's going to look like, because this now, I'm not sure, does this actually create like an instance of this that is local to this file? It might actually do that, but the point is that we want this G here to be a pointer. So maybe it needs to be this, and then it needs to be address of that or something. Bar. Oh, it's actually like that, right? Yeah, now we have global data. There we go. So it's supposed to be just var and then global data. The problem here is that this is now global data. This G pointer here is global data. So this would need to be patched up. We don't want that either. Because then again we need to go into all of these and patch them up. Yeah, that's interesting. Yeah, this simplifies the syntax here, but this won't work unless we do like a reassignment of this thing later on. Well, we can do it if we have like a pub fn set g or something. PTR is pointer to a basis global data physics scene. Void. Like this, and then you just set G to be pointer. And then this thing could be there we go. It could be just global data. Undefined, for example. So we would actually have a function here that sets that stuff. Or, you know, if we don't even need a function, we just need it to be public. Like this. Yeah. So we can take that away from there. Trying out different approaches here. So we would have global data, and then we would have a pointer to a global data. They would both be public. And then you would have the global data actual instance, which has like an instance of that. And then this could have like a hookup function or whatever we want to call it. Setup. Void. And then we will go to basis, physics scene. G is the address of G physics data. Physics scene, like that. And then when we do the hot update, hot reload, whatever, there will be more here. We will run this setup function again. And it would patch up those pointers there. Like, I don't think this is necessarily that big of an issue, as long as you have a sort of a convention for how you do these things that you follow everywhere. You could have a single global var in the root sig file and then import it everywhere using import root.g. That way only patch one variable. Would that work though? Like, that's kind of what I had earlier. And I had a sneaking suspicion that would not have worked. But let's say I fix up these things here first. So like we do gdg. Actually we need to do like, yeah, that needs to become g.io. And then that's g everywhere. And that's that. I'm just fixing this up so that I can actually see if we get any errors here. The LSP gets tripped up on these things if we don't fix them. Right, do we have any g.g's left? Yep, there's one. Right, so let's say we have it like this. We have a G pointer here. Now in the root file, we were here already. What you're saying is basically I would have a pub var global data, or let's just call it G, of type globe. This would be, yeah, it would actually probably be this global data dot. Well, no, it would just be this, right? Undefined. Except I would probably call that something like global data, like this. because it's a type now. So what you're saying is I would have this, right? And then in here I would import. How do I import that without it just being a type, right? Like I can do like const g is address of, you know, import. Let's do import first. So basis zig g. That's a global data. So what if I can I do that? That would be a var. Like my issue here is that, okay, I don't know what this actually does now. I've never written anything like this. Duplicate struct member G, okay, G2, whatever. This now gets a pointer to this G here, right? However, what if we, and correct me if I'm wrong here, Volodymyr, but if I just maintain this global data instance here, right, and we do like a mem copy, for example, so we copy all the global data over to this guy. When we load the new data, well, okay, it will. Okay, I can sort of see this working if we just keep this here as actual global data. Yeah, that would probably work. What I was thinking we would do is that we would keep it in the heap so that we wouldn't need to mem copy anything. But this could be actually a viable thing. If we mem copy from this in the old library to this in the new library, and then we have this, I guess we should be able to actually use it directly with this G2 pointer here. I've never done anything like this. Does the standard library do anything like that? No, doesn't seem to do. You could have the G in basis be a pointer to the global data. That would be a pointer. Pointer to that. We don't need that actually. So that would be a G that points to this guy. It's kind of unclear to me where this memory now lives, because I've only been doing these things as sort of like forward declarations of types. But I mean, we can at least do this G storage or whatever, right? And then just do global data. Right, now it is at least clear to me where that thing is. It is found here, right? Right, now that's a const type. Yeah, okay. Yeah, see, that's the difference. Now this is a const type. We don't want that. We want it to be a pointer to a global data. There we go. So we define, essentially, sort of like, we define the global data here. We create an instance of it here, and we get a pointer to it here. And then here, we don't need to do that anymore. We can just do import. And that would be the pointer. At least as far as I know. And of course we can just do basis. We don't need to do it. We do basis G. And then we could do G2 down here. So really, actually, what I would want to do here is this const G2, or actually const G is basis.g dot global data pointer. It doesn't want to show me anything. Basically what I want is that, right? Right, I want the address of basis.g, then dereference this guy and get the physics scene out of it. Is that really what it's called? No, it's called G physics scene, no underscores or anything like that. Why do you need the storage bar if you place it? Yeah, if I that's what I said previously. If we put it, I don't need this if you put it on the heap. That's exactly true. I don't need it if you put it on the heap. I was thinking if we don't put it on the heap, if we do a mem copy. Yeah, mem copy would imply that it's not on the heap. If it's on the heap, then we don't need this at all. And then we can do something like... then we can do here, we can do something like... well, we don't really have a nice place for it here, but let's imagine this is an initialization function of some kind. Then we can do this, and we can set that to undefined, and then we can do G is basis mem heap allocator. Yeah, we need to basically create a new one of these guys. Let's pretend we get assigned to us a heap allocator here. We essentially need that as well. So means allocator create and then do global data catch panic OOM, something like that, right? Yeah, we don't have all of this stuff here, but that's basically what we would need to do. And of course this we only do once, we don't do it every hot reload. So yeah, if you put it on the heap, we don't need the storage there. I was thinking specifically if we do keep it on the as actual global data. Yeah. Yeah, like CLS doesn't even know what to think about this. It's like unknown. But this would essentially be a pointer to a global data. I'm not sure the syntax here is correct, actually. That may be how it should be. But yeah, something like this. So then if you expand this to more different files, essentially, you take all of your current global data, you wrap it in a struct like this, and then you go here and you create an instance of it here. And we don't need that setup thing there at all. That can just be, just be like that. And then you get a pointer to it like this. Something like that would probably work. But I need to test this out. This is a new way of doing things for me. There's one of these places where like Zig's module system kind of makes my head spin like a little bit. I'm like, okay, well that is a type. That's a type, but that's also kind of something that you can just go and assign things to, right? You can just go and go like global data dot physics scene dot, I don't know, IO is something. So it's kind of like a type, but it's also an instance of something. This is definitely an instance, and this is a pointer to an instance. But yeah, I think this is solvable. I think this is definitely solvable, and my plan is, because I'm gonna have to end the stream pretty soon. We have been going for over 5 hours at this point, yay! So I think this is a pretty good cutoff point for today. We did all kinds of crazy juggling of things. So it was a pretty good stream. Even though it kind of calmed down with the chat towards the end, but anyway, my plan is this. I'm gonna figure out how I want this global data to work, and I'm gonna make sure it actually does work, so that we can get it copied over. And then I'm gonna probably do another stream where I play around with this hot reload functionality. That should be fun, and we can maybe even do some game dev, some actual honest to god game dev with this system, because this should allow us to do all kinds of cool things much more easily. But yeah, this requires a little bit of tinkering and fiddling. I don't think that's necessarily super interesting stream material, so I'm just gonna skip over that, and you guys get to watch me play with the thing when we have it working, and then we'll go through how I solved all that. That's my plan, and I hope it sounds good. But that'll be it for today. If you want to play the game, which we haven't seen in a few hours here, really, except for some empty screens, but if you want to play the game, and you can check out the beginning of the stream where we played the game quite a bit, then be sure to join the Discord, where you can get a Steam playtest key for Pre-Alpha 3 today, and mess around with it. And if you want to support the project but you don't want to play it right now, go to Steam and add it to your wishlist. Links to both the Steam page as well as the Discord can be found in the beginning of the chat and also in the description below. And yeah, be sure to like and subscribe so that you get notified when I do the next part. Walkthrough once this is done would be appreciated. Absolutely, I will do that. And if you happen to miss the live stream, all of these are available as VODs on the channel as well. But yeah, do subscribe, and I will try to let you know a little bit, at least a little bit in advance, when the stream goes live. So hopefully I will see you next time. Have an excellent rest of your day, everyone, and see you next time.